0.
Okay. Good morning, everyone. Any anniversary is a feast worth celebrating. Today is a silver jubilee of an institution that shifts the paradigm of the 21st century education to a level at par from the basics. Silver is the metal most noted for this anniversary due to its radiance and brilliance, which MTG has been continually honing from the jewels and the champions of our country in mathematics. It is my distinct honor and high privilege to welcome you all to the MTG's 25th anniversary celebration, an event to celebrate an important milestones in MTG's quest towards excellence in safeguarding quality and distinctive mathematics training to our dear teachers and to our young champions. Before we begin the celebration, we would like to acknowledge the presence of our guests, especially our partners from Sharp Calculator Philippines, to our speakers and lecturers in this morning's celebration. And of course, we acknowledge the presence of the reason for such great celebration. Mrs. Erlinda Pisibal, President of Phoenix Publishing House Incorporated, our COO at MTG Philippines, Dr. Simon Chua, our MTG President, Dr. Isidro Aguilar, our Executive Director, MTG, Mr. Robert De Colacion, and our MTG advisor, Ma'am Mirna Agtara, and other officers and board members of MTG Philippines. It is our pleasure to welcome all of our teachers and trainers at this webinar of Phoenix Publishing House Incorporated in celebration with the 25th founding anniversary of MTG Philippines. We are excited to have each and every one of you here because we're going to experience a unique celebration of 25 years in service of MTG for our educators and for our Philippine champions. To start the program, we would like to invite everyone for a prayer to be led by our MTG advisor, Ma'am Mirna Agtarap, and this will be followed by the singing of the Philippine National Anthem.
Pas, wala nga si Ma'am Astarap. Pambasang awit siya lang. Pambasang awit siya ente. Yan mucho. Pambasang awit siya ente.
Mga kababayan, ang pambansang awit ng Pilipinas. Kayang magiliw, elas ng silanganan, alam ng puso, sa titik mo'y kubay, lupang binirang, tuyag ng magiting, sa manluluping, di ka pasisigil, sa nagatak tutok sa simoy at sa langit mo bagaw, ay hinagang tula, kawin sa pagkayang minamahal, ang isang lang matawag mo'y tagumpay na nag-iingin, bakit tuwing at araw niya kailan pang ay di magtitingin, luwag ang araw ng warhabit pagsika, buhay langit sa piling mo, ang hinigaya na pagkay bangangin, at mamatay ng dahil sa'yo.
Opo. Pero okay naman, Doc Arch. Nag-view ako ngayon sa Facebook. May sounds doon.
Meron? Okay, sige, sige. May technical problem daw. May technical problem daw.
Good morning po. Good morning po, MTG.
A pleasant. Yes, a pleasant morning, dear teachers. Today is a very special gathering and a unique way of celebrating and appreciating the valuable efforts and determination not only of our champions, but of our mentors, being the experts in the field in recognition of their fortitude to help the teachers and the Philippine champions to go beyond limits. Phoenix Publishing House Incorporated
Yes, a
has a
pleasant
longtime
morning,
partner
dear teachers. Today is a
celebrates
very
the
special
25th
gathering and a
anniversary
unique
of
way of
MTG
celebrating
Philippines
and
by
appreciating the
sponsoring this
valuable
webinar
efforts and
entitled
determination
Articulating
not
Learning
only
Goals
of
through Mapping Up Mathematics Contents and Concepts. This is accredited with 4 CPD units. A quarter of a century's promise of promoting competent and confident teachers and champions. Today, we are gathered as one community of math learners seeking for new learnings, excited for new Olympiad experience that this seminar provides us towards mathematical maturity. It is but right to start this celebration with a welcome. So let us listen to one of the pillars and mentors we have at MTG Philippines. Let us all welcome with a virtual applause the President of MTG Philippines, Dr. Isidro Aguilar, to give his welcome remarks.
I would like to acknowledge and congratulate all the people who are behind this initiative.
one of the
To
pillars
our
and mentors
founder,
we have at
Dr. Simon
MTG
L.
Philippines.
Chua,
Let us all
MTG
welcome with a
Executive
virtual
Board,
applause the
to our
President of
full-time
MTG
members,
Philippines, Dr.
our
Isidro Aguilar,
trainers
to
and
give his welcome
coordinators,
remarks.
and most especially to our educators who are watching us now from all
I would
parts
like
of
to
the country.
acknowledge and congratulate
Because
all the
of
people
all of you,
who are
our
behind this
knowledge
initiative.
One of the
banks
pillars
became
and
once
mentors we
more
have at
filled
MTG
as we
Philippines.
brave
Let us
the
all
new
welcome
normal
with a
in
virtual
education.
applause the President
Before
of
I
MTG
start my
Philippines,
message,
Dr. Isidro Aguilar,
I would like you all to
And
imagine
most especially
two people
to our
swimming in a race. The
who
first
are watching
swimmer
us now
dives
from all
in
parts.
and quickly swims
And
to the
congratulate
other side
all
of the
of
pool.
you who are
The
behind this
second
initiative.
swimmer
one of the pillars
dives
and mentors we
in,
have at
but
MTG
after a
Philippines.
few seconds begin to swim like dog
Before I
rather
start
than
my
swim
message,
to the other end
I
of
would
the
like
pool.
you all to imagine
If you look
the two
closely,
people
the
swimming in a
second
race.
swimmer
The
tries to
first
stay
one
afloat.
dives
In fact,
in a quick
he is working
and
as
to
hard
the other side
as the first swimmer.
who are behind
But
the
are
second
both
swimmer.
swimmers making the same amount of progress? It is clear, no. The second swimmer is working but hard but not making the progress. Now, let me ask you as a teacher, are you incorporating activities that keep students afloat? Or are you using activities that actually help students reach an end goal where they experience progress? Mathematics Trainers Guild Philippines, or MTG, since its establishment in 1995, has placed engagement as the heart of its programs, plans, and activities. It has been our battle cry to forward the agenda of mathematics excellence and influencing teachers to sharpen their pedagogical skills in mathematics because math is life. These long years of our initiatives made us amazed to see our students who were then participants to the famous 12 Saturday program, the Mathematical Challenge for Filipino Kids training program, into excelling into fields that involve mathematics, both conventional and unconventional, engineering, applied mathematics, and physics. A lot of them are internationally situated, affirming our missions to hold them in international standards. These students are a product of years of on-point engagement between their teachers and themselves. That without the teachers' effort to engage their students, there would be no professionals who will excel on this field. But through the years, mathematics and excellence has become asymptotes. You know that they are existing, but it seemed that they can't meet, as if we are teaching math to help students stay afloat but not enable them to reach an endpoint with progress. Now, our job as math educators is to prove that these two asymptotic lines are in fact interesting lines, that these two lines, mathematics and excellence, meet in a point of intersection. This can only happen through a meaningful math engagement. The researchers studying the science of learning have revealed that true engagement happens when the learners have a personal connection with the content that allows a deepening understanding to occur, unlike 10 to 30 years ago back when we were students, where math content comes from our all-knowing teachers. 21st century students or the Gen Zs has access to different resources like a huge pile of math wisdom. They have YouTube videos, math hacks, and a lot of books. So, we just have to do more than just dumping all this content into their minds. We need to make all these numbers and content around them meaningful and useful in their future endeavors by providing opportunities for learners to be able to engage with content through exploration and hands-on projects and activities, so that at the end they will have ownership in the learning process and maximize their engagement, because mathematics has proved itself to be at the heart of our existence as human beings. The patterns in our environment shows by the Fibonacci sequence and different interaction of polygons and circles. The exactness of our choices reflected in combinatorics and the boundless application of function in things that dominate our daily lives. All these wonders make us think that mathematics engages us and makes us feel that mathematics is one with our lives that is so powerful that a pandemic like COVID-19 cannot surpass. Teachers, let our battle cry be, let E in mathematics be engagement, so that we can see a future that is filled with engaged math learners.
Thank you so much, Dr. Aguilar, for the warm welcome and a bracing message. With all being said, we are getting more and more excited for the rest of the morning. A wake-up call to us teachers to be more dynamic and more engaged educators. Truly, math is our passion, math is our life. And now, for the opening remarks, we would like to call in a partner of MTG Philippines in bringing quality in Philippine education. Let us all welcome Mr. Edmond Padre from Phoenix Publishing House Incorporated.
I am Mr. Edmond B. Padre, the Managing Editor for Math at Phoenix Publishing House Incorporated. Dr. Simon L. Chua, Chief Operating Officer, MTG Philippines. Dr. Isidro C. Aguilar, President, MTG Philippines. Mr. Roberto De Gulacion, Office Director. Dr. Eduardo O. De la Cruz Jr., Vice President, MTG Philippines. All the distinguished officers and consultants of Mathematics Trainers Guild Philippines, the world-renowned mathematicians, speakers, and mathematics trainers who are with us today, distinguished delegates, school administrators, and mathematics teachers, both from private schools and public schools. it is my privilege to address you on behalf of Ma'am Penny Sibal Balbin, the Executive Vice President of Phoenix Publishing House, Incorporated. Phoenix Publishing House, Incorporated advocates for the improvement of the quality of education here in the Philippines. Together with our competent authors, we produce instructional materials that are challenging, that do not underestimate our students, that honor the students and recognize their potential, propelling them to achieve academic excellence and preparing them to compete in the international arena through innovative teaching and effective learning. This has been our mantra at Phoenix. We are your partner in innovative teaching and effective learning. The Executive Vice President of Phoenix Publishing House Incorporated and Phoenix Group of Companies asked me to express on her behalf our sincerest thanks and gratitude to Mathematics Trainers Guild Philippines for always putting in outstanding work of organizing intensive trainings in math. MTG's commitment to promote excellence in mathematics education has always been an inspiration to all of us. We often hear and read of the achievements of Filipino students in international competitions in math, and countless times, the people behind these achievements are math teachers who are members, trainers, and officers of the MTG Philippines. Thank you, MTG, for making it possible for our Filipino youth to compete and succeed in the global arena. MTG has already shown countless times that achieving this level of excellence in math is very possible. To the people behind MTG, mabuhay po kayo. This COVID-19 pandemic is really terrible. While we continue to take care of ourselves and our loved ones, observing social distancing, frequent hand washing, and staying at home most of the time, I think we could all agree that life goes on, learning goes on, and our mission continues. The distance learning scenario, in general, made our jobs as math educators even more challenging. Admittedly, there are students out there who find the subject quite difficult to keep up with. Depending on how the teacher handles the individual learners in his or her class, a student has to work hard to a certain extent to keep up. First, I would like to point out that this is an opportune time to be understanding, to empathize with our students, and show to our students that we care for them. In these trying times, the cheerful math teacher who genuinely cares for his or her students will prove to be the most effective. Second, this is also an opportune time to teach up. That is, continue to set the bar high while equipping our learners to learn how to learn. Learning how to learn now, more than ever, proves to be a very important skill. Teachers who teach up ensure that the learners develop the skills of independence and self-direction, which are necessary for success. We at Phoenix Publishing House Incorporated are one with MTG, and we are one with all the teachers who are with us in this webinar, pushing the boundaries and wanting the students to soar in math and succeed at the highest level. We all want the best math education for our students. We want to see how far our students can go in the local and in the international arena. Dear teachers, your commitment to never-ending improvement, as attested by your participation in trainings and webinars such as this, is in itself already your contribution. All this for the love of your students, for the love of math, and for the love of learning. My admiration goes to all of you. Thank you for putting in the work. You are here today because you feel the burning desire to make a difference in this world and in the lives of your students. Thank you for your commitment to competence. On behalf of Phoenix Publishing House Incorporated, and in the spirit of our shared vision with Mathematics Trainers Guild Philippines, through our partnership that has already lasted for more than 2 decades and counting, it is my pleasure and privilege to welcome you all to this webinar. Have a great experience ahead. Again, to our dear teachers and to MTG, more power. Thank you.
Thank you so much, Mr. Edmond Padre. A remark worth of an opening. Thank you for being a comrade of MTG in honing our champion skills and abilities to an unfathomable height. MTG had been true to its promise of ensuring quality trainings with sophisticated solutions and out-of-the-box take on problems and challenges that spark a wow factor to our dear teachers and champions. And we who are here in this celebration is more than honored and appreciative of this opportunity of learning from best of the best. The purpose set forth for this celebration is a shatterproof effort of MTG's quest in contributing in the development and advancement of mathematics educations in the Philippines. MTG's mission of institutionalizing excellence in mathematics educations and training in the Philippines in order to upgrade the discipline to meet international standards and to provide basis for scientific and technological manpower needed for country's education, modernization, and industrialization. This promising mission has been a seal of assurance delivered for 25 years and counting. MTG's continued quest for excellence brought opportunities for international undertakings that shows the world that we can. Today is a celebration of learning from experts beyond compare. As a starter, before we begin the pool of lecturers we have, let us listen to our speaker as he helps us focus on the first 5 minutes of our class. Our speaker is currently the Chief Education Supervisor, Schools Governance and Operation Division of DepEd Mabalacat. Let us all welcome with a virtual applause, Dr. Roger Nuque.
My respect and greetings to the MTG family, spearheaded by Dr. Simon Chua. Let me engage you to my topic for today, how to make class time really count. Time to focus, the first 5 minutes of class matter. One of the assets of an instructor is to make good use of the warm-up minutes. Many students are also present in mind, while others have begun the transition from the distractions outside the classroom to the learning within. The first 5 minutes should be akin to flipping a switch. It is the time to cement their focus on learning, on the relationship, and the discussion in the hour to come. It's not much about doing any deep content. It's more about just getting them into the moment of the class. You start with open with a question. It's a tactic instructor often used to try and spark discussion, but it can also fall flat if students don't engage from the outset. Thinking strategically about the question can generate better results. The idea of predicting is that when people have to wrestle with something or try to make a guess or predict or solve a problem before they're ready, this is actually very helpful for their long-term learning. Ask the student a question to which they do not know the answer, before which the course had already provided some of the answers building the blocks. In other words, you help them thinking. You help them try to look on a new perspective. What do you already know? It is actually a specific question that can be used repeatedly because it serves a very specific and evergreen learning objective. This is a surefire technique to improve student learning, to begin class by revisiting not just what they've learned the previous lesson, but what they already know on the subject matter. This technique is helpful for faculty as it forces students by getting students' knowledge and misconception out in the open in the first 5 minutes of class. Instructors can gauge how well-versed their students on a particular topic. That way, wherever you plan for a class, that they can specifically deal with and improve upon the knowledge actually in the room. Another technique is giving poll question. Whether through clicker systems or show of hands as a way to gauge students' prior knowledge or attitudes, or even to verify that they've done the readings. It would be very easy to see class with 5 quick poll questions based on the reading that the student had made, then using that as a way to get started and see what the students are. Another way is actually writing exercises. No more than 5 to 10 minutes in length and often based upon the questions he has devised to spark the discussion. Once they write down their answer, you found they're sort of more curious than to hear what the GAP taught. In other words, 5 minutes is very important to setting the tone of the teaching learning process. One of the insights is that the role of a teacher in a young student's life goes beyond just education. They are leader, role model, a coach, an advisor, and a facilitator of positive growth. With the students spending most of their time waking hours at school, it's up to the teachers to create a positive and inspiring environment where children can do their best work. Let me end my short talk by these words to ponder. The mind is not a vessel to be filled, but a fire to be ignited. So let's flourish our mind every day. Let us be productive. Good morning, and thank you very much.
Thank you so much, Dr. Roger Nuke. It was indeed an inspiring way to start our class and our session this morning. This is not just another gathering, but this is a gathering that celebrates a quarter of a century's pursuit for excellence. This is a gathering that gives us an avenue to be open and be enriched with new learning adventures that will advance our knowledge and skills as teachers and trainers into a different level of understanding through distinguished speakers. Wow, this is really an exciting celebration to begin. With high caliber speakers, surely we'll learn a lot from them and we'll have full pack wisdom to store. So let us not keep everyone waiting. Let us start with our speakers from the elementary level. Our first speaker is a faculty member of Stonyhurst Southville International School. Let us all welcome with a virtual applause, Ms. Queenie S. Flores, as she shares with us her topic on visualizing word problems in grade school.
Good morning. Today, we will be discussing one of the most powerful cognitive tools in problem solving, which is the visualization. The ability to solve problems is at the heart of mathematics. Visualization is at the heart of mathematical problem solving. The concept of visualization is to form a mental image with the aid of tools such as a pencil and paper or computers. Visualization is the ability to see and understand the problem situation. Visualizing a situation or an object involves mentally seeing various alternatives for solving a problem related to a situation or object without benefit of concrete manipulatives. The teacher models the difference between a pictorial representation and a schematic representation. It's an image that shows the relationships among the problem parts. This is crucial because the representations must show the relationships among the problem parts and incorporate relevant information in the problem. Asking students to make observations, connect their ideas, identify their thinking, and look for evidences will help increase thinking strategies across all disciplines. Good thinkers create a picture in their heads as they read the problem. Having a mental picture of all that the problem entails can encourage them to persevere until they find a solution. Now let's have the first example. In the figure, line AB is equal to line BC, line CD equals to DE, equals to EF, and equals to FA. The area of the whole figure is 120 square centimeters. Find the area of the shaded part. Let's have the first solution. Draw lines as shown. 6 identical triangles are formed, and it's equal to 120. 2 identical triangles shaded is equal to 2 over 6 multiplied by 120, which is equal to 1/3 of 120, or 40. The area of the shaded part is 40 square centimeters. Let's now have the second solution. Draw lines as shown. Looking at the newly drawn lines, 6 identical segment triangles are formed. Pay attention to the 2 parts shaded pink. Each pink shaded part has a matching unshaded part. Switch the corresponding parts. 2 of the 6 identical segment triangles are shaded. 6 identical triangles are equal to 120. 2 identical triangles shaded is equal to 2 over 6 multiplied by 120, or 1/3 multiplied by 120, the product is 40. The area of the shaded part is 40 square centimeters. Let's now have example number 2. A rectangular garden measuring 26 by 21 meters has a 5-meter walking path running through it. Find the area of the walking path. Here's our solution. Remove the path and join the 2 garden parts. This forms a shorter rectangle measuring 26 minus 5 meters by 21 meters. That is 21 by 21 meters. Longer rectangle is equal to the product between the length and the breadth, wherein the length is 26 and the breadth is 21. Then the product is 546. The shorter rectangle has a product of the length and the breadth. In this case, they are both equal to 21. Multiplying these 2 factors, the result is 441. The area of the path can be computed by subtracting the longer rectangle by the shorter rectangle. It's now equal to 546 subtracted by 441, which is equal to 105. The area of the walking path is 105 square centimeters. Example number 3. The figure below shows a rectangle WXYZ with 2 identical right-angled isosceles triangles cut out at diagonally opposite corners. The area of the shaded figure is 264 square centimeters. Find the area of one of the triangles. Here's the solution. Shift one triangle so that both triangles join to form a square. This is what we will get. Draw lines as shown, and there are now 3 shaded rectangles. Rectangle 1 is equal to the product between 6 and 1u, or 1 unit, resulting to a product of 6u. Rectangle number 2 is equal to 24 multiplied by 1u, or 24u. Rectangle number 3 is equal to the product between 24 and 6, resulting to an answer of 144. The shaded parts has an area of 144 added by 24u added by 6u. Combining similar terms, we now have 144 added by 30u. We all know that the shaded area is 264 square centimeters. Equating both values, we now have 144 plus 30u equals 264. Combining all the constant values, we now have 30u equal to 264 subtracted by 144. 30u is equal to 120. To solve for u, we simply divide 120 by 30 to get a quotient of 4. So it means that 1 unit is equivalent to 4. Now let us calculate the area of one unshaded triangle. Unshaded triangle is equivalent to the formula 1/2 multiplied by the base multiplied by the height, which is the same as 1/2 times 1u times another 1u. Substituting the value for our 1u, we have 1/2 multiplied by 4 multiplied by another 4. The product is 8. So the area of one of the triangles is 8 square centimeters. This time we'll go to example number 4. The figure below shows a rectangle that is cut into 4 triangles A, B, C, and D. Find the area of triangle D. Here's our solution. Draw lines as shown. The rectangle is divided into 4 small rectangles of different sizes. Within each small rectangle is a diagonal line. Each diagonal line cuts its respective small rectangle into 2 equal parts. That means any one part is 1/2 its respective small rectangle. Logically, if we take 1/2 of every small rectangle and combine those areas, we get 1/2 the rectangle. So A plus C is equal to 1/2 of the rectangle. Now you can take 1/2 of every small rectangle as follows. That means that B plus D, which is also equivalent to 1/2 rectangle, will now become B plus D is equal to A plus C. Since our B has a value of 40 square centimeters, we're going to substitute it by 40. Plus D, in this case, this is what we're asked to look for. Our A is equivalent to 40 square centimeters, and our C is equal to 58 square centimeters. Doing now the addition on the right-hand side of the equation, we have 40 plus D equals 100. Combining the constant values, by transposing 40 to the other side, we have the equation D is equal to 100 minus 40. And the difference is 60, which is equal to our D. The area of triangle D is 60 square centimeters. So these are the examples in which we can apply the visualization strategy. Thank you for listening. I hope that you learned something from our discussion today.
Thank you so much, Miss Queenie Flores, for that out-of-the-box experience of doing things and visualizing word problems. Now, for our second speaker is a Dean of School of Education at Arellano University, Pasay. Let us all welcome with a virtual applause Dr. Archibald A. Rodriguez, who will talk about tree planting problems.
Good morning. I am here to discuss about problems on tree planting. Once again, I'm Dr. Archibald A. Rodriguez. To start, to understand the mathematical problems in tree planting and learn how to solve them, the key is to understand the relationship between the following. First, total length and the number of trees, and the distance between the trees or the interval between the trees, and the number of trees. Usually, there are two cases on how to solve tree planting problems. First, planting trees on enclosed routes such as a line segment, broken line, circular arc, and others. The relationship between the number of interval or the space between two trees and the number of trees can be divided into three categories. First, if both ends have a tree, to find the total number of trees, it would be equal to the total number of intervals plus 1. Next, if both ends are joined, total number of trees would be equal to the total number of intervals. Or if trees are planted at one end and no trees are planted at the other end, to find the total number of trees, it would be equal to the number of intervals. And if no trees are planted at both ends, the number of trees is equal to the number of intervals minus 1. Case 2. Tree plantings on closed routes or closed loop, such as circular swimming pools, rectangle, square, and closed curves, and others. To find the number of trees, it would be equal to the number of intervals. Some quantitative relationships commonly used in tree planting problems are number of intervals is equal to the length of the road divided by size of each interval. Length of the road is equal to the size of each interval times number of intervals. And the size of each interval is equal to the length of the road divided by the number of intervals. Some application of tree planting problems in daily life are inserting flags, climbing stairs, wood sawing, bell ringing, rope cutting, and others. The word tree planting does not appear, but the essence of the problem reflects the relationship on problem of tree planting, so it can be solved by the method of tree planting. As our example 1, a newly widened highway is 400 meters long. Coconut trees will be planted on both sides of the highway at every 8 meters interval. Letter A. How many coconut trees will be planted at both ends of the highway? B. How many coconut trees will be planted only at one end of the highway? And letter C. How many coconut trees will be planted if no trees are planted at both ends of the highway? So there are three things to remember here. The length of the road, which is 400 meters long, the coconut trees to be planted on both sides of the highway, and the interval of 8 meters. So from the given information, the highway is 400 meters long. The distance between every coconut tree is 8 meters, or the size of the interval. Then there are three possible cases to calculate the number of coconut trees. Since the coconut trees are planted on both sides of the highway, so there is a need to multiply by 2 after finding the number of coconut trees. To answer question A, when both ends have a tree, finding the number of trees is equal to the total distance divided by size of interval plus 1 multiplied by 2. We know that the distance is 400 meters divided by 8 plus 1 times 2, and that will give us 102 coconut trees to be planted on both ends, or both ends of the both sides of the highway rather. So as you can see from the drawing, coconut trees were planted on both ends of the highway. For letter B, when trees are planted at one end only, the total number of trees is equal to total distance divided by size of interval times 2. And that would be equal to 400 divided by 8 times 2. So therefore, there will be 100 coconut trees to be planted. So in this drawing, one end of the highway will not be planted by coconut tree. Next, to answer letter C question, when no trees are planted at both ends, the number of trees is equal to the number of intervals minus 1 times 2. So therefore, that would be 400 divided by 8 minus 1 multiplied by 2. The answer is 98 coconut trees. So as you can see from this drawing, both ends will not be planted by the coconut trees. For our next example, a wall is 4.9 meters long. Mr. Rivera hangs 5 pictures, each with length of 50 centimeters on the wall. The distance from the edge of the wall to the nearest picture and the distance between any two nearest pictures are equal. Find the distance. So sometimes we need to draw what is being asked in the problem so that we can easily answer or solve the problem. Okay, so as you can see from the drawing, there are 5 pictures hanging on the wall. And each picture, the length is 50 centimeters, while the length of the wall is 4.9 meters. So to find the total length of the pictures, that would be 5 times 50 centimeters. So the total length is 250 centimeters. And the next would be finding the total length of the 6 intervals. So first is we have to convert 4.9 meters into centimeters, and that will give us 490 centimeters. So 490 minus 250 is equal to 240 centimeters. That is the total length of the 6 intervals. Therefore, length of each interval is equal to 240 divided by 6, which is equal to 40 centimeters. That 40 centimeters is the distance between any two nearest pictures and the distance from the edge of the wall. Third example, the lampposts were placed along a circular pond at every fixed interval of 5 meters. There were 12 lampposts altogether. Find the circumference of the pond. So therefore, this problem is a closed loop. So as you can see, there were 12 lampposts. So to find the distance around the pond is 12 times 5, which is the interval, and that would be equal to 60 meters. Example 4. A road is 300 meters long. At every fixed distance of 50 meters, a tree will be planted. How many trees are required if both ends of the road do not have any tree? So from the given information, this is an open route. To find the number of trees, first, find the number of intervals. And that would be 350 meters, which is the length of the road, divided by 50 meters, which is a fixed distance. Hence, the number of trees would be 350 divided by 50 is equal to 7. So therefore, the number of trees would be 7 minus 1, and that would be equal to 6 trees. Fifth example, A rectangular corridor of a flat is 24 meters by 40 meters. A flag is hung at every 4-meter interval. Find the total number of flags hanging in the corridor. The perimeter of the rectangular corridor would be 2 times 24 plus 40, and that would be equal to 128 meters. So a rectangular corridor is a closed loop. The total number of flags hanging in the corridor would be 128 divided by 4. That would be equal to 32 flags. Next, the circumference of a circular pond is 840 meters. If 24 benches are placed along the pond at an equal distance, find the distance between any two benches. So to find the distance between any two benches, that would be equal to 840 divided by 24. That would be equal to 35 meters. So that problem is so easy. Mr. Tan hangs 14 pictures on the wall. Each picture is 185 centimeters long, and the distance between any two nearest pictures is fixed at 60 centimeters. He hangs the first picture and the last picture at both edges of the wall. Find the length of the wall. So there will be 14 pictures to be hanged on the wall. So what is the length of the wall? The length of the wall is, that would be the one that we're going to find out. So the distance for every picture is 60 centimeters. And the length of the picture is 185 centimeters. There will be 14 pictures all in all. So to find the length of the wall, it is equal to 14 times 185 plus 13 times 60, because there will be 13 intervals altogether. So therefore, that would be 3,370 centimeters or 33.7 meters. That would be the length of the wall. Richard plans to build a fence enclose a square garden plot. The perimeter of the plot is 96 meters, and he sets posts at the corners of the square. The posts along the sides are set 6 meters apart. How many posts will he use to fence the entire plot? From the given information, the figure of this problem is a closed loop. So the formula to be used is the number of intervals equals length of the road divided by size of each interval. So from the given, the length of the road is 96 meters, and that would be the perimeter of the lot. So 96 divided by 6 is equal to 16. So the number of posts for the entire plot is 16. That's all. Thank you very much.
Thank you so much, Dr. Archival A. Rodriguez. Your thorough examples and explanation made everything crystal clear. Our third speaker is proficient in the field of mathematics, one of the mentors in MTG Philippines. Let us all welcome with a virtual applause, Mr. Renard Chua, who will talk about mathematical puzzles for grade school.
Good morning, everybody. So for today, my topic will be mathematical puzzles for primary school students. So what will be our agenda for today? Basically, what we're gonna do is we're gonna spend time discussing some of the puzzles that we can use to supplement our students in time, especially in times like this. So right now we are in a pandemic and we do remote learning, right? So I think having puzzles in our activities will help stimulate and keep the students locked in during these times. Okay, so first I'll just briefly talk about benefits of puzzles. So basically, it adds uh, it adds an intellectual dimension to the sensory delights of handling elegantly crafted materials of color, shapes, and textures. It also helps us exercise our brain and sharpen our wits. And good puzzles are puzzles that are solved by logical thinking and are not solved by chance or luck. Okay? So for puzzles, you can do it on your own. Even you yourselves are like the educators can also do these puzzles to stimulate uh, our logical and creative thinking. So some main psychological benefits of puzzle solving are as follows. It improves memory, it develops creativity, and teaches us new ways of thinking about other everyday problems. Okay? So there are many kinds of puzzles out there, but for this talk, I will focus on three different parts only. Mainly matchsticks and toothpicks puzzles. So that's the first one. Then polyominoes would be the second one. And I selected some international contest problems for us to solve together, and that is the third part. So there will be three parts altogether. All right. So now we will proceed to the first puzzle, which is the matchsticks puzzles. Okay. So some quick introduction about this one. So basically, this one it's just using sticks, like sticks of the same size, and you play around with it. Okay. So how do we apply this during this time? So my suggestion is you can ask. So since a match and the stick is not really child friendly, what you can do is you can uh, use maybe some popsicle sticks for the students to use. So basically, ask them to get something and then try to simulate all these exercises. Okay, this these kinds of puzzles will help improve logical thinking as well as geometry introduction. So like if you're teaching geometry, like squares all have equal size, so they can form it so that they can reason out that yeah, that is a square and so on. Okay. So in the next few slides, we will be having some examples of the some exercises about these puzzles. These puzzles actually, if you can just easily search in Google. There are many puzzles with regards to sticks and matches. All right. So first example is this one. So you have two squares here. So uh, you have two squares here. Let me. Yeah, you have two squares here, and the instruction is just move four matches to make 3-unit squares. Okay, so this one sometimes you can like after discussing the concept of square. Right now, you can give this as a quick exercise, right? So another good thing about sticks and matches puzzles is that it doesn't have uh, a finite or a very specific solution on how to get it. Basically, you will ask your students to think outside the box. So basically, think through on how they will answer. Also, most of the time, there are multiple solutions to it. So that gives them more creativity in answering these kinds of puzzles. So to get the answer, yeah, here. So here, notice that you cannot get 4 matches from the outside. Otherwise, it will be it won't be a square already. So what you're gonna do is remove the 4 middle ones to get this one, or you can also remove this part, this part, this part, and this part to form this one, right? So here you have 1, 2, and the big one, and here you have the 2 by 2, the 2 by 2, and the 1 by 1. So you have 2 answers for this one. All right. Next, another one. So we quickly go through this puzzle. So move 3 matches to make 2 unit squares. So again, I'll just quickly share, but you get the idea. You let your students play around with the puzzle. There. So you remove this 3 and you form this 3. Then you get 2 squares. One is a 2 by 2 square and one is a unit square. Next, now you need to remove a square twice. So move 2 matches to a new position to get only 4 squares. There. So yeah, you remove this part and move it there. Now you get 4 unit squares. All right. And here, remove 9 matches so that no square of any size remains. So this one has many solutions. I'll share one. So here, notice that there are no squares. These are just 1 by 2 rectangles and a 1 by 3 rectangle. Right? So these are good puzzles. Like after introducing concepts in geometry, you can ask your students to play around with this. Also, you can use it in triangles as well. So move 3 matches to make 4 equilateral triangles without overlapping. So the answer is this one. So you remove 1, then you place it here. So you have 4, meaning 1, 1, 1, and the small one over here. Right? Next, so here, moving 4 matches to form 3 equilateral triangles. So similarly, you remove this, this, and this, and then you have 2 equilateral triangles of size 1 match and 1 that is size 2 match. Right. Then some other ideas. So from here, from this figure, you can introduce the concept of similarity as well. Right? So I think playing around with the puzzle is very good to stimulate the brain at the same time to introduce concepts. So now you can introduce similarity here as well. And here, so this I think is the last one for matches and sticks. So make these 3 into 6 with no breaking of pieces. So this requires some ingenuity. But if you teach Roman numerals, you can easily do that. So yeah. So from 3, it becomes 6. So you need to ask them to solve this after you have introduced Roman numerals to the students. All right. So that there are lots of stick and matches puzzles online. So do search for them, and I hope you give your students some puzzles to try, even just once a week. I think a weekend activity would be great. added supplement for their learning. Next is polyominoes. Okay, so this one, I'll have a quick introduction, then afterwards we'll solve some puzzles. Okay. So what are polyominoes? Basically, for polyominoes, they are shapes made by connecting certain number of equal size squares, each joined together by at least one other square along the edge. So this puzzle was invented by Professor Solomon Gollum in the Harvard in 1953. So there are many forms of puzzles that use polyominoes as a basis, like our usual Tetris, then top this. So top this is this one, and then square by square. So you'll form many patterns, and they are basically examples of combinatorial geometry, the branch of math dealing with the way in which geometrical shapes can be combined. These patterns are good in stimulating interest for mathematics for students, especially for the young ones. So let us try to look for some examples. So this one is a monomino. So it's just basically a one unit square. Next, we have domino, and it can take two shapes, this one or this one. But it's just the same. Okay, so for domino, even if it's this or this, it takes only one shape. Okay, so usually in any combinatorial problems that follow, it is assumed that polyominoes can be rotated 90, 180, 2070, or 360, right? But yeah, it's the same, right? It's the same figure. Now we have trominos using three different shapes. And for trominos, we have two different shapes. One is just a 1/3 rectangle, and one is like an L. Right? Now we have a tetromino. Yeah. So there are 5 ways: I, L, N, O, T. Right? Pentomino, we have 12. So I'll quickly show you all of them. Yeah. And hexomino, there are 35. Okay. So for this, I think it's a good exercise for your students to try different shapes. Let's try different shapes. So using 4 unit cubes, how many shapes can you form? Yeah. Some simple activity like that. Okay. So now let's try to do some examples. So for this problem, draw walls to partition the grid into areas so that each area contains 2 dotted squares. Area sizes must match those shown below the grid, and each plus must be linked to at least 2 walls. So basically, we have 4, 4, 5, 5, and 7. Then 2 dotted. Let's count the black dots: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so that's correct. So we need to make 5 different partitions into that each partition have 2 dots, right? So I'll just very quickly go to the answer. So the answer is like this. So you will notice that this part is 1, 2, 3, 4, 5. So that's 5, and there are 2. That's correct. 1, 2, 3, 4, 5. So there are 5 as well, and there are 2 dots. So that's correct. 4 and 2 dots inside. That's correct. This one is 4 and 2 dots inside. That is correct. And what remains is 7 and 2 dots inside. That is correct. Okay. This puzzle builds confidence in your spatial intelligence, as well as after introduction of area to the students, you can ask them to try this puzzle, right? Right. Next, I'll very quickly go to this one. So 3 out of the 5 tetrominos have symmetry lines. Now, use any 2 tetrominos to form a symmetric figure. How many different pairs are there? So notice here that I, O, and T are symmetrical if you cut them in those red lines, while L and N doesn't. Okay, so now the question is asking combining one symmetrical and one non-symmetrical. How many pairs are there that are symmetrical? So this question you can introduce after you introduce what symmetry means, right? So we'll quickly again go to the answer. Yeah, so there are 6 different pairs. So N and T. So this is T and this is N. So it's symmetrical here. N and L, if you place it like this, it's symmetrical here. And the rest are as shown. All right. Now for problem 3. Is it possible to arrange an odd number of L tetrominos in rectangles? If yes, what is the least number? Yeah, so since we want odd number of L tetrominos, we can quickly just try using 3, 9, 15, and so on, right? So just keep on trying. So this one is good if it is being done in groups by students. Okay, so I'll just quickly again go to the answer. Yes, it is possible, and it is a 9 by 5 figure, and the figure is shown here. Okay, do note that solving these problems, the time range may vary. It can be solved in like as little as a minute, but it can also be solved in 10 or more minutes. It really depends on how the students attack or visualize the problem. All right, I'll just quickly go through. So another question here is, this is a more challenging question already. What is the least number of pentominoes that can be placed on an 8 by 8 board such that none of the remaining ones can be added? So the answer here is the minimum is 5, and one solution is shown here. All right. And our last question for this one. So this one is from a mathematical contest. It's from the 2016 IMC for high school team contest. So dissect the 6 figures in the diagram below into 12 pieces, each consisting of 5 squares, such that no 2 of the 12 pieces are identical up to rotation and reflection. Okay, so again, this is good if it's being done in school. So maybe next time, if we're back to normalcy, we can try to solve this. And the answer is just like this. So basically, all 12 pentominoes were used, and this is how you split it. All right. And now we proceed to our last few numbers. So these are just some more puzzle problems for that I will share with you so that you will be exposed. So here, Peter arranges 5 poker cards on the table as shown in diagram 1. Then he rotates one of them. Now the 5 cards are shown in diagram 2. So from the 5 cards here, he rotated one, and it becomes like this. Which card among A, B, C, D, or E has been rotated? Okay. Okay, so what do you see? So this is basically just a visualization. Notice here that for 7, if it's rotated, this diamond will become at the bottom, right? For 9, this clover, this middle clover shape will be upside down, should be, but it's still the same. So it's not rotated. For 7 as well, it's the same. For 8, it's the same, right? For 9, if you rotate this one, the heart will be the same, right? And for 8, notice that now it's 5 facing up and 3 facing down. If you rotate this one, then it will become 3 facing up, 5 facing down. But notice they are the same, right? So that leaves us with no other choice but 10 was rotated, right? Since these 4, if you rotate it, it should be in a different placement. While for 10, notice that it's symmetric. So our answer for it is 10 clover has been rotated. All right. So this is from 2012 IMSO. Another one is this one. So basically here you will this is a very classic puzzle. You will fill in the 6 by 7 table with the numbers 1 to 42 so that it makes a straight line, right? So I'll just quickly jump to the answer. So yeah, this one. So basically it's just 1, 2, 3, 4, 5, 10, 13, 15, 16, 17, 18, 26, 27, 28, 29, yeah, and so on. Till it reaches 42. All right. Yeah. And we go to our last question. Okay. So for our last question, this is in the arrangement below, each number is the non-negative difference of the two numbers above it. What is the average of the 8 positive values of z? Okay. So if you are faced with this kind of question, usually some students will try to fill out all of the numbers, but in solving this kind, since we just want z, we focus on this part only, right? This part is just we don't need it anyway, right? So how to solve it? So here we just have to do working backwards. So working backwards, it is easy to see that w should be 6, right? There's no other value for w. Now for x, since the difference is 6, it can be 34 minus 28 or 28 minus 22. So you have two values for x, 34 or 22. Its average is 28. Okay? So doing so with y, there are 4 values in y, and the 4 values of y is 34, 38, 14, or 58. Okay? Notice that its average is also 36. So what you can notice is that w is 6, x is 28, y is 36, which is the same here. So using that pattern and using the same logic, the average of the 8 possible values of c must be 76, right? Just to cut time, we don't need any way to get all of the values because what we're being asked is the average. All right? So I hope you learned something new today. I hope you try to integrate as well puzzles. This will stimulate creativity and logical thinking to our young learners. Thank you very much and have a great day.
Yes, thank you so much, Mr. Renarcho, for the distinct puzzles you shared with us this morning. It really made our brain cells working. Great brain teasers and mind benders to begin our class. To relate it to Dr. Nuke's talk earlier, make the first 5 minutes interesting for our class. And for our last speaker for elementary, we have a junior high school faculty member from Zamboanga Chonghua High School. Let us all welcome with a virtual applause Ms. Jezebel Amoroderos on her lecture about using assumption method smartly.
Good morning, everyone. I am Teacher Amor, and welcome to the 4th session. I am going to talk about using assumption method smartly. I hope that you will be able to find something useful along the way. And since we are going to talk about assumption method, we need to know what method was right. Remember that every method is different ways to solve different problems. So, shall we begin? Let's try and learn problem number 1. Natalie had 40 birds and rabbits in her farm. If she counted 106 legs in all, how many animals of each type were there? Let us assume that she had 40 birds, and in each bird it has 2 legs. So get the product of 40 and 2, that is equal to 80 legs. But we know that when we subtract 106 legs and 80 legs, there is a shortage of 26 legs. And this means that she needs to replace some birds with rabbits. Then the difference between the legs of rabbit and birds is equal to 2 legs. So for each bird replaced with a rabbit, we have 2 legs, which means 2 legs would be added to the total number of legs. So divide 26 legs by 2 legs, that is equal to 13, and that 13 is the number of rabbits. And after you get the number of rabbits, subtract it from 40. So 40 minus 13, that is equal to 27. So we have 27 birds. Hence, there were 13 rabbits and 27 birds. Letty has 9 sticks of 2 different lengths. The long sticks are 3 times that of the short sticks. Each of the short sticks is 150 centimeters long. If the total length of the sticks is 2,850 centimeters, how many long sticks and how many short sticks does she have? Now let us make the assumption that all the sticks she had were short sticks. Then the total length of 9 short sticks will be the product of 9 and 150 centimeters long. So that is equal to 1,350 centimeters. So the difference in length from actual length of the sticks is equal to 2,850 centimeters subtracted by 1,300 centimeters, and that is equal to 1,500 centimeters. From the given information, the length of each long stick is equal to 3 times the short stick. Then the length of each long stick will be the product of 3 and 150. So let's multiply 3 and 150. That is equal to 450 centimeters. It follows that the difference in length between each long stick and short stick is 450 and 150. So let's get the difference. It is equal to 300 centimeters, and the number of long sticks would be the quotient of 1,500 and 300. So let's divide. 1,500 divided by 300, that is equal to 5. Thus, Letty has 5 long sticks, and we subtract that 5 from 9, then we have 4 short sticks. So the answer is, in a question, how many long sticks and how many short sticks does she have? Letty has 5 long sticks and 4 short sticks. Another problem, we have Sally participated in a math quiz. For every correct answer, 10 marks were awarded. For every incorrect answer, 5 marks were deducted. If Sally scored 55 marks for answering 10 questions, how many questions were correct and how many questions were wrong? We first make the assumption that Sally answered all 10 questions correctly, so we multiply 10 and 10, that is equal to 100 marks. Then we know that for every question answered incorrectly, Sally get 15 marks less than 100. So take note that it is for each incorrect answer. So 10 marks would be taken back on top of that, and 5 marks were deducted. Then 15 marks must be deducted from her perfect score. Since it was given that Sally scored 55 marks, so Sally's score was the difference of 155. That is equal to 45 marks lower than the perfect score. So 45 marks was the excess or the extra marks. And that is equal to extra 15 marks plus extra 15 marks and another extra 15 marks. So it follows that Sally has 3 incorrect answers, and in order to know the number of correct answers, we will subtract 3 from 10, and that is equal to 7. Therefore, there are 7 questions were correct and 3 questions were wrong. Next problem. In a farm, there are 24 geese and goats. Gavin counted a total of 84 animal eggs. How many animals of each type were there? In order to solve the number of animals, let us make the assumption that all the animals were 24 geese. So multiply 24 and 2, that is equal to 48 legs. But the difference of the number of legs between the actual number and the assumption is equal to 36. Okay, so we subtracted 84, which is coming from the given problem, and that 48 legs, which is coming from the assumption. So this is the shortage. And we also know the difference in the number of legs between a goat and a goose. So we subtract 4 legs and 2 legs, that is equal to 2 legs. And the farm have, in order to get the number of goats, we divide that 36 legs, that is the shortage of legs, by 2, and we have 18 goats. So 36 divided by 2 by 18. And it follows that we subtract that number of goats from the 24, which is given from the problem. So 24 minus 18, the difference is 6. Therefore, there were 18 goats and 6 geese in the farm. The next one. Erica has 30 coins worth $13.50. If all the coins are either 50 cent or 20 cent coins, how many coins of each denomination does Erica have? Second question is, what is the value of all the 50 cent coins in dollars? So let's solve the given problem first. How many coins of each denomination does Erica have? So we assume that all 30 coins are 50 cent coins. So we multiply the 30 coins by the 50 cents, that is equal to $15. And after that, we subtract that the number or the total amount of assumption that we have by $13.50 to check how much is the excess. And 15 minus $13.50, that is equal to $1.50. So that excess is the given 150. So let's set aside that one. Next, we also subtract the 50 cents and the 20 cents to get the difference of the 2 cents. So we have 30 cents. And what are we going to do is to divide the 1 cent and $1.50, which is the excess, by 0 or 30 cents. Okay, again, we divide $1.50 by 30 cents, and that is equal to 5. Okay, so that 5 is the number of 20 cent coins, which is given from the coming from the given problem. and we subtract that 20-cent coins from the number of coins given from the problem, that is 30 coins. So the difference is equal to 25, and that will be the number of 50-cent coins. So which means that the answer is Erica has 5 20-cent coins and 25 50-cent coins. And then for letter B, what is the value of all the 50-cent coins in dollars? So let's multiply that $50 by 25, and that is equal to 1,250 cents, and convert that 1,250 cents into dollars. That we have $12.50, since $1 is equal to 100 cents. Okay, are you ready for the next problem? Now we have another one. A delivery man was asked to deliver 3 more than a dozen parcels on a particular day. He earned 425 pesos. How many parcels were safely delivered? Now we have the table for how much the delivery man earned for every safely delivered, and that is 45 pesos. And the delivery man compensates 5 pesos for every broken parcel. Now, before you solve the given problem, we have to identify first the given, and that is the statement wherein there is a 3 more than a dozen parcels. So we should know how many parcels do we have in all. So let's add 3 and 12, that is equal to 15 parcels. So we have a total of 15 parcels. And the next thing to do is to assume that all 15 parcels were safely delivered. So which means that we will multiply 45 pesos and 15, since the delivery man earns 45 pesos for every safely delivered parcel. So 15 times 45, and that is 675 pesos. And the next one is to add how much do you have for every safely delivered and a broken parcel. And so 45 plus 5, that is equal to 50 pesos. So in order to know how much is the excess, we will subtract the 675, which is the assumption of the 15 parcels, and the 425 pesos, which is the earnings the delivery man earned in that delivery. So the difference of the two is equal to 250 pesos, so that is the excess. And we divide that excess by 50 pesos, and that the result or the difference of that given is equal to the number of the broken parcels. So 250 divided by 50, that is equal to 5. And after that, in order to know how many parcels were safely delivered, we subtract that 5 from 15, and that is equal to 10. So we have 10 parcels were safely delivered as the question from the given problem. So that will be our answer. Now, are you ready for the next problem? We have a worker was asked to deliver 100 vases. He got $10 for each vase he had delivered, but compensated $20 for each broken vase. He collected $700. Find the number of broken vases. Now take note the given of this problem. So we have 100 vases. We have $10 for each safely delivered, and $20 compensated for each broken vase. And then he collected $700 in all. So we don't know how many vase was safely delivered and how many were broken vases. Now, in order to solve this problem, the first thing to do is to assume if all vases are safely delivered or when all vases are broken. So it's up to you. You have to assume. And after that, you have to get the total amount of money wherein the vases has safely delivered and the broken vases. And after you get the total amount of money, we divide it or we subtract it from the given 100 vase. So let's try. Again, we have to assume that all the 100 vases were properly delivered without any broken vase. And then the worker would have received $1,000. So we multiply the $100 and $10. Okay, again, $10 is that's what he earned in every safely delivered vases. And after that, we'll get the total amount of $20 and $10, that is equal to $30. So for each broken vase, we subtract also the $1,000, and that is the assumption that we have, and the amount of money that he collected from the given problem. So that is $700. And the difference of the two is equal to $300. So divide that $300 by $30, and that is equal to 10. So the number of broken vases is 10. Okay, are you ready for the next problem? Johnny uses 352 centimeters of wire to make 10 small and big squares. The side length of each small square is 4 centimeters. The side length of each big square is 5 centimeters that of a small square. How many small squares does he make? The same process that we are going to do. We have to give an assumption. We have to get the total. We need to divide and get the difference. So let us make the assumption that all the squares Johnny makes are small squares. So from the given problem, the side length of each small square is 4, which means that the perimeter of that is to get the product of 4 and 4, then we have 16 centimeters. And after you get the product of the small square, get the side length of each big square. So 5 times that of the small square, therefore 5 times 4 is equal to 20 centimeters. And then get the perimeter of each big square. Since the big square is equal to 20 centimeters, we will multiply that with 4, and that is equal to 80 centimeters. After that, we have the total perimeter of 10 small squares, and the 10 small squares are given from the problem, which is the 10 small and big squares. But from the assumption that we need to assume that all are small squares. That's why we have 10 times 16, that is equal to 160 centimeters. And after that, we get the difference in length from the total length of wire used. So from the given problem, from the given information, that we have the length of wire, which is the 300. 92 centimeters. So the perimeter of each big square more than each small square is the difference of 80 and 16. So 80 minus 16 is equal to 64 centimeters. And we know that 192 centimeters is equal to the sum of 64 centimeters, another 64 centimeters, and another 64 centimeters, which means that the number of base squares he made is 3, and that's 64 centimeters. So 3, and the small squares is to subtract 3 from 10, so we have 7. Therefore, he makes 7 small squares. Next problem. Mrs. Aguilera baked 25 cakes for sale. She could earn $12
Yes,
for
ma'am.
every cake she sold. Otherwise, she would have lost $5, which was the cost of the baking materials. She earned $215. Find the number of cakes she had sold. Have you thought of an answer? So let's assume that Mrs. Aguilera sold all the 25 cakes. So multiply 25 and $12, that is equal to $300. After that, we'll think of how much she would have lost for every unsold cake. So let's add $12 and $5, that is equal to $17 for each unsold cake. And from the given assumption, we will subtract the amount she earned, which is 215. So 300 minus 215, that is 85. And that's the time that we divide the 85 and $17 for each unsold cake. So the number of unsold cake is equal to 5. And in order to know how many cakes were sold, so 25 cakes minus 5 unsold cakes, then we have 20. Therefore, Mrs. Aguilera had sold 20 cakes. Next problem. A rabbit and a turtle will run a competition of 10,000 meters. The rabbit's speed is 5 times the turtle's speed. After they start, the turtle keeps running, but the rabbit stops on the way and sleeps. When the rabbit wakens, the turtle is 5,000 meters ahead of it, so that the rabbit runs immediately. However, when the turtle reaches the ending point, the rabbit is still 100 away from the ending point. During the period of the rabbit's sleep, how many meters did the turtle run? Suppose that the rabbit didn't sleep, then when the turtle reaches the ending point, it runs 10,000 meters, and the rabbit could run 50,000 meters. So we multiply that 10,000 and 5, so that's why we have 50,000 meters. However, the rabbit runs only 9,900 meters. So get the difference of 10,000 and that 100 away, because from the given problem, it says that the rabbit is still 100 away from the ending point. In another word, the rabbit runs 40,100 meters less because it takes time for sleep. And if you're asking where is the 40,100 meters coming from, so that's the 50,000 that was the assumption before, and we subtracted that 9,900 when the rabbit runs only. So after that, because the rabbit's speed is 5 times the turtle's speed, so during rabbit sleep, the turtle could run 8,020 meters. So that 8,020 meters is the quotient when we divide 40,105. Therefore, when the rabbit sleeps, the turtle has run 8,020 meters. And that will be our answer. Let's proceed to another problem. Jimmy spotted a total of 11 spiders and ants in his garden. If he counted 74 legs altogether, how many spiders and how many ants did Jimmy see? We all know that spiders have 8 legs and ants have 6 legs. We first make the assumption that all the creatures Johnny spotted were ants. So from the given problem, or from the given information of 11 spiders, we multiply that 11 by 6, and that is equal to 66. Then the number of extra legs is the difference of 74 legs, which is given from the problem, and 66, that is the assumption of the total number of legs. So get the difference of 74 and 66, that is equal to 8. So a spider has 2 more legs than ant, and then the extra 8 legs means that we have extra 2 legs, another extra 2 legs, another extra 2 legs, another extra 2 legs. In other words, we have the sum of 4 extra 2 legs. So the number of spiders is equal to 4, and the number of ants is the difference of 11 and 4. So 11 minus 4 is equal to 7. Therefore, Jimmy saw 4 spiders and 7 ants. Now we have one last problem. 4 swimmers A, B, C, D made a prediction on their performance before the swimming competition. A said, I will definitely be in the first rank. B said, I am absolutely not in the 4th rank. C said, it is impossible for me to be in the either 1st or 4th rank. D said, only I am in the 4th rank. After the competition, it is found that among their predictions, only one person is wrong. Whose prediction is wrong? First, suppose that this prediction is wrong, then the other 3 predictions are correct, so that the conclusion is that no one is in the 4th rank, and it is conflicted with the fact. Therefore, this prediction is correct. Then suppose that C's prediction is wrong, then it means that C is either in the 1st rank or in the 4th rank. However, if it is so A and D is wrong, so that 2 people are wrong, it is conflicted with the condition. Therefore, C's prediction is correct. Next, suppose that B's prediction is wrong. Then B should be in the 4th rank, but it is conflicted with this prediction, so B's prediction is correct. At last, A's prediction is wrong. Alright, this is the end of our session. I hope that you have learned something about using assumption method smartly. So if you have questions or any clarifications about the topic, you may comment down below and ask about it. Again, I am Teacher Moore, and thank you for listening, everyone. Stay safe. Goodbye.
Thank you so much, Miss Jezebel Amoroderos, for stimulating examples which really put the trainers in a different level of thinking. That's an engaging and interesting experience, a true celebration of mathematical learning for our elementary trainers. Today marks a milestone of a quarter of a century of discovering wonders behind MTG's quest towards excellence. So, let's watch this video presentation and be mesmerized from the humble beginning to being the forefront of international level of academic excellence that brings Philippines to the winds. So sit back, Relax as we enjoy watching MTG's milestones.
I feel your world is sudden proud, and your words are sudden loud. At night, I can't stay here inside, 'cause my pain grows way too tight. Your electric heart shakes me out of love. I don't wanna feel like this. I'm alone, burning here like this. Your electric heart shakes me out of love. I don't wanna spend my life like this. I'm alone, like this, like this, like this.
That was indeed a fascinating presentation which shows how MTG has flourished from four to more. A huge reality that transcends expectations and anticipations. Since we are on the height of our celebration, we will be having our first set of raffle. We encourage the participants to type present and thank you in our live FB page of MTG. It will be drawn later, so the 200 winners will be posted in our MTG Facebook page. And our sponsors for this raffle are Phoenix Publishing House Incorporated and SIBS Publishing House. Thank you so much for your support. It will also be posted how you will claim your prize from the raffle draw. And now, we are blessed to have Sharp Calculator Philippines as MTG's partner in this endeavor. Are we ready to know who will be the winner in one of our major raffle prizes? To our dear elementary teacher participants, you have a chance to win a Sharp Calculator EL-W531XH model, and this is pre-drawn. So, are you ready? Our winner of Sharp Calculator EL-W531XH model is, drum roll please, we have a teacher from Pinaglabanan Elementary School. Congratulations to Ma'am Wilma Rosales. Thank you so much, Sharp Calculator Philippines, for sponsoring our major prize for this day. Later, it will be announced again, and later it will be posted how you're going to claim your prize. Congratulations. Yan. So it's not only a celebration, but it's also a celebration of wonderful gifts from blessings from our partners as well. So let's not keep our high school trainers and teachers waiting. Of course, we also have a lot in store for the high school trainers and teachers. So for now, let me introduce our first speaker. To our high school trainers, and if the elementary school would like to join with us, you are very much welcome to be with us in this morning's activity for high school. Our first speaker made this celebration extra special because of his presence as one of our lecturer, and his lecture will surely be noted by our dear participants. To our math trainers and teachers, let us all welcome with a virtual applause the director of MTG Philippines, Dr. Simon Chua, as he unraveled the wonders of mathematics for high school.
Good morning to all my colleagues. This morning, I'd like to share with you some of the ways of solving complex problem. Maybe those problems may produce complex solution, but we can do it in a simple way. The very first time I encountered this kind of problem is when I was a substitute teacher in a certain Chinese school. There's a teacher who tried to solve a problems. Actually, that is a Russian addition of Russian expression. And then because of the denominator cannot be factored out, so he want to simplify it and it becomes really complicated. This morning, that will be my first problem that I'm going to share with you. In fact, I tried to convert it so I try to revise the problem, okay? Instead of just finding maybe the addition or subtraction of the Russian expression, I try to do it as finding the sum of all the roots of the equation. Okay, so this is our problem. We have, what is the sum of all the roots of the equation? That is 1 over x squared plus 11x minus 8 plus the second expression. We have 1 over x squared plus 2x minus 8 plus the third expression. We have 1 over x squared minus 13x minus 8 is equal to 0. Okay, because we find out that all the denominator cannot be factored. So maybe if we want to simplify it, what we are going to do it is just as the same as the simple arithmetic. We want to get the LCD, so it becomes really a complicated, okay, expression. Now, take a look to these three Russian expression. Of course, the first one is you have x squared plus 11 minus 8. And the second one is x squared plus 2x minus 8. And the third one is x squared minus 13x minus 8. What common properties or what common expression you can find out for these three? In fact, it will be easy for us if we try to consider the middle term, because we have x squared plus 2x minus 8. This one, no? X squared plus 2x minus 8. If we try to let this to be our y, let x squared plus 2x minus 8 to be the y equals to y, then what will happen to the first expression, the denominator of first expression? That means x squared plus 11x minus 8 will becomes x squared plus 2x minus 8 plus 9x. So that x squared plus 11x minus 8 will be treated as our y, variable y. So that means we can come up with a easier expression. And the third one, the third Russian expression here, which is x squared minus 13x minus 8. How do you get the relationship with the x squared plus 2x minus 8? What we can do here is we can express that as x squared plus 2x minus 8 minus 15. So if we can do that, that means we're going to start with letting x squared plus 2x minus 8 is equal to a y. So if that expression is equal to y, then we can have this expression x squared plus 11x minus 8 as follow. So you have y plus 9x. You know what is your variable y is x squared plus 2x minus 8. If you plus 9x, then that will become the origin expression. And the second expression is 1 over y, and the third expression is 1 over y minus 15x. So the whole is equal to 0. At this time, we find out it's very easy for us to simplify the expression. So that means if we try to get the LCD, or we try to multiply the whole equation, this rational equation, by y plus 9x times y minus 15x. So the first expression, after simplify, we're going to have y times y minus 15x. While the second expression, that is 1 over y, will become y plus 9x times y minus 15x. And the third expression will become y plus 9x times y. So if we try to simplify them, we are going to come up with this one. 3y squared minus 12xy minus 135x squared is equal to 0. And as we know that all these three terms are multiple of 3. So let us divide each of them by 3. And this is what we have. Y squared minus 4xy minus 45x squared is equal to 0. And as you know, it is obviously that this can be factored as y minus 9x times y plus 5x is equal to 0. So now, since the product of two expressions is equal to 0, so it's either this is 0 or the other one is 0. So that is why we can set up y is equal to 9x or y is equal to negative 5x. So let us try to substitute each of them to the expression, to our original expression. That is x squared plus 2x minus 8 is equal to y. Replace the y by 9x or replace the y by negative 5x. So that is what we have it here. So we have x squared plus 2x minus 8 is equal to 9x, or x squared plus 2x minus 8 is equal to negative 5x. So simplify each of them, we give us this one. X squared minus 7x minus 8 is equal to 0. And the next one is x squared plus 7x minus 8 is equal to 0. And we find out that each of them can easily be factored. Okay? X squared minus 7x minus 8 is equal to 0 can be factored as x minus 8 times x plus 1. While x squared plus 7x minus 8 is equal to 0 can be factored as x plus 8 times x minus 1 is equal to 0. So we find out the value of x as follows. So x could be 8, negative 1, negative 8, or positive 1. So these are the four roots of our original rational equation. And if you try to substitute each of them, you find out they are really the solutions of our original rational equation. So, since our problem is to find out the roots, sum of all the roots of these four, so we have 8 plus negative 1 plus negative 8 plus 1. So we have the answer is 0. So that is our first problem. That is how we solve it in an easy way. Now, so I hope from now on, if you encounter with complicated expression, you can easily try to apply this kind of substitution method in order to simplify your complicated expression or to finding the roots. So now, let us have a second problem. This second problem is actually looking for maximum or minimum. Here in our problem is we want to find the minimum value. And this is the problem. What is the minimum value of the algebraic expression? X squared plus 4 plus the square root of quantity 12 minus x quantity squared plus 9. How can we solve this kind of problem? It's really quite difficult. If we are, because of the radical sign, and we know that it cannot be just simplified at all, so we have to try to look for some expression, maybe some geometric expression to interpret each of them. Interpret this x squared plus 4 and this 12 minus x quantity squared plus 9. So in order to do that, this morning I suggest let us try to use the number and figure combination methods. How do you do it? Actually, let us try to start with interpret this x squared plus 4 by using a rectangle. So we have a rectangle here. Okay. We are going to consider one side as x, the other side as 2. And we know that it is not yet enough for us to solve this. So let us try to come up with another rectangle. And we have it here. So for this one, let us try to consider the AB as our whole length. So the AB will be 12. If AB is 12, then we can have some other portion. Okay? So if AB is 12 and if this is x, if this portion is x, then this one will be, because the whole is 12, so 12 minus x, this will become this portion. And so if this is x, we can consider this as 2. So if we try to apply the Pythagorean theorem, you have 2 squared plus x squared, which we can easily get the length of EC here. And for the other one, if this considers 12 minus x, and the width is considered as 3, because we know the square root of 3 is 9, and the square root of 12 minus x is this expression. So again, we can apply Pythagorean theorem to look for the hypotenuse or the diagonal here in this rectangle. So we know this is the length. EC represent square root of x squared plus 4, and CF represent the square root of 12 minus x quantity square plus 9. So let us try to connect EC and connect CF. And we have this one. Yeah. What did we find out? Actually, after we have the EC, length EC and length CF, we can come out a third side, because we can consider EC as the first side of the triangle and CF as the second side. So let us try to draw the third side, which is this one. And from triangle inequality, we know that very clear that the sum of the length of two sides of the triangle is always greater than the third side. So using this concept, we can come up with the solution as follows. So first, as shown in the figure, we have AB is equal to 12 and C is equal to X. Then it followed that BC will be 12 minus X, as I just mentioned a while ago. And let us consider AC as the length and 2 as the width of the triangle, of the rectangle ACDE. So we can find out the hypotenuse of the right triangle, EAC. So using that kind of concept, it will help us to solve the problem easily. Because the same, we have we have C is equal to square root of X squared plus 4. And similarly, we can come up with CF, which would be square root of 12 minus X quantity square plus 9. plus 3 squared, so that is 9. And apply the triangle inequality, we know that CE plus CF are supposed to be greater than the third side, which is EF. And you see, if we try to take the sum of CE and CF, that is our requirement, that we want to find out the square root of x squared plus 4 plus the square root of 12 minus x quantity squared is plus 9, which we want to find out the minimum value of this algebraic expression. So once again, we know that EC plus CF will be greater than EF because of the triangle inequality. Okay? Because we know that those three are not in the same line. Okay? So we can come up with the triangle inequality. Therefore, EC plus CF will be greater than EF, and of course, if we try to simplify, that square root of 12 squared plus 5 squared, and that is 13. That means EF is equal to 13, or EC plus CF must be greater than 13. And this value of EF of EC plus CF is 13. That is why we have the solution. The minimum value of the original expression is 13. So this is how we share with you these two problems. And these are the common problems that you encounter during in the second year or third year, or even fourth year high school. So here, we try to have the fourth problem here, the third problem. And the third problem here is even very popular, no, in most of the textbook. And then at this day, they consider as routine problem. That means you want to simplify square root of 3 minus square root of 5 minus square root of 3 plus square root of 5. So how shall we start with this problem? Because we know that the square root of 5 is 2 point something. That is why 3 minus 2 point something will give you square root of a positive number. And of course, the second term, 3 plus square root of 5, that will also give you 3 plus 2 point something, which is square root of 5 point something. So, of course, each of them are positive. That is why we mention it here. Square root of 3 plus square root of 5 are greater than 0. Similar with square root of 3 minus square root of 5 is also greater than 0. And we know if we take the difference of the two, okay, this one minus that expression, the answer of course will be positive. But our problem is not square root of 3 plus inner square root of 5 minus square root of 3 minus square root of 5, but it's in the other way. So that is why we know the original expression is negative of square root of 3 plus square root of 5 minus square root of 3 minus square root of 5. So we want to find out how can we simplify, how can we get the final value? How can we get the numerical value of this expression? So, as you know that we can consider the square of this and then taking out the square of that whole expression with a negative outside. So that is how we have it. So the original expression can also be written as negative the square root of the quantity square root of 3 plus square root of 5 minus the square root of 3 minus square root of 5 quantity squared. And of course, we know that this is our first term and this is our second term. So you have maybe to apply a minus b quantity square, you can simplify it. So this is the square of a minus 2 times this times that, and then plus the square of the last term. So that is why we have this one. Yeah, this is what I mentioned. So if we try to simplify each of them, this one will give us 3 plus square root 5. This one will be 3 minus square root 5. So the square root 5 will be cancelled out because of one is positive and one is negative. So, and of course, the middle part is square root 3 plus square root 5 times the square root 3 minus square root 5. So apply a plus b times a minus b. So that is why 3 square minus quantity square root 5 squared. So we know that this will be 6. And this one is 9 minus 5. So that is why 9 minus 5 will give you 4. And 4, the square root of 4 will give you 2. That is why 6 minus 2 times 2. 2 times 2 is 4. So that is why we have our final answer, which is negative square root of 2. So these are the problems that most of the time we encounter in the classroom. But of course, they belong to the challenge type of problem. Actually, some of them are not even considered as challenge, but because of the complicated in the solution. So it appears that we try to share with you some techniques of solving this kind of problem. And I think so this ended my sharing time. Thank you very much for listening.
Yes. Thank you so much, Dr. Simon Chua, for invigorating and thought-provoking problems that you shared with us this morning. It is a complicated math made easy. I'm sure it provided a smile on every teacher's face. Thank you, because it provided a smile on every teacher's face as the solutions are presented in a sophisticated manner. It is truly an honor and a great privilege to hear from the expert. And now, our second speaker is proficient in the field of mathematics as well, one of the mentors in MTG Philippines. Let us all welcome once again, with a virtual applause, Mr. Renard Chua, who will talk about how to make math more interesting in classroom setting for high school.
Hello. So I'm back. So for the high school teachers, actually for elementary, if there are still elementary teachers around, it is applicable to you as well. So our agenda for this topic is basically how do we want to eliminate the stereotype for students. Usually students fear math. So our goal is to eliminate that and to make math more interesting in the classroom. Okay? So we'll start off with figuring out what are the main concerns, why the students are not interested or is fearing math. Then I will give some ideas for you to apply so that math will be much more fun and loved by students. All right. So first, we start off with why does math always have a bad reputation? So first, it's I think it's because of a dependence on memorized concepts or formulas. Okay, so like for example, sometimes they just memorize the formula without knowing what is the idea behind it. The problem with that is as you go along your academic journey, some of the previous concepts you still need to bring towards the newer ones. And if you don't know the reason or idea behind that, then that will make some problems moving forward. And from that, sometimes the students will get discouraged from repeated practices or challenges. So since the idea is not clear to them, the problem will be as they go into higher math, which needs that a previous idea. Therefore, it presents some challenges to them. And because of those challenges, it leads to frustration so that they don't love math anymore. Instead, they hate it already. So the goal is to eliminate the idea that math is hard. So how do we do that? So first, I think as educators, we need to focus on teaching the basic concepts rather than on formulas. Okay. Yes, sometimes formula is okay, but the whole idea is they need to understand why is it like that. Like for example, in geometry, they need to understand the properties like why does the sum of the interior angles of a triangle always equal to 180? How about for quadrilaterals and so on? Not just like why is it 180? So we need to show them why is it 180. Okay. And instead of using familiar problems, try to add alternative problems that are non-routine. Okay, so this will be a bit tough, but I'll give you an idea on how this will be applied later on. Okay, so sometimes problems that are routine can also be given a fresh new approach. All right. And then the emphasis should be on the thinking process in problem solving. So the whole idea is that in maths, it's not the final answer that matters the most. What matters the most is how you were able to arrive with that answer. So I think that is something that needs to be reinforced every once in a while. Sometimes we have this notation that we just need to get the answer. Yeah, but for me, the thinking process, and I'll show it. I'll show you why later on. And of course, lastly, intuition plays a big role in creative mathematics. So that's why we emphasize the thinking process, because intuition plays a big role, which drives abstract and logical and creative. Okay, so here are some examples on or activities that we can do to make it more interesting. First is we promote non-routine problems. So we can promote logical puzzles or this one is because just to stimulate their interest with maths. Okay, just to pull them through in. And then solution writing session, since I'm telling you that more important thing for me is the solutions or the journey. So solution writing sessions should be done once in a while so that you'll see how the student answered the problem. So there are many ways to solve a problem. So you'll see how they attacked it. And then we also you try to introduce some strategies from time to time. So for this, you would be familiar with lots already, like working backwards, finding a pattern, visualization, which were discussed, right? So for this topic, I'll introduce two strategies. One is invariant, and the other one is plus minus one strategy, just for this topic. But generally, the whole idea is just for you guys to try to, from time to time, introduce some strategies. That way, students will be more energized to solve. And lastly, I'll proving without words. So, before I end this talk, I have a problem that I will be proving just one problem, but I will be proving it 5 different methods. All right. So we start with our exercises right now. So first, example 1. So this is taken from IMSO 2015. So the question goes like this. In the expression 5 blank, 4 blank, 6 blank, 3, Place each of the three operational symbols plus, minus, and times exactly once into the three blanks and list down all its possible values. What is the largest possible value of the resulting expression? Okay, so for this, the main goal for us is to know how many different ways can we place the plus, minus, and times there. Okay, that's the more important part than getting all the values. Okay, so basically the basic combinatorics is pretty important here than just you can list it down, you can use combinatorics to get it. So basically it's just we have 6 different permutations to place those signs. And out of those 6, so if we know that that is 6, that is the most important one. And then we just get the values. And we will know that we're being asked the largest possible value. So it is 26. All right. Now next we proceed to example number 2. So this is if you read through this, it looks like a routine age problem. This is taken from IMSO 2012. 2 years ago, Steve was 3 times as old as Bill, and in 3 years, he will be twice as old as Bill. Find the sum of their ages. Now, okay. So from here, usually, if you are familiar with age problems already, you will just set up the equations, right? So what you will do is something similar to this one, right? So you just set up the age of Steve and Bill to be X and Y. Then solving, you will get 17 and 7, and your answer is 24, right? This is the typical way we solve algebraic problems. But what if I suggest we do the same? So same question, but we try a different approach in solving this. We don't really use algebra, but we just use visualization or thinking. So what we can do is something like this. Since 2 years ago, Steve was 3 times as old as Bill. So if Bill is X, then Steve is just 3 of those segments, or 3X. Then in 3 years, he will be twice as old as Bill. So 2 years ago and 3 years, so that's plus 5, right? So after 3 years from now, the age of Bill will become X plus 5. And we know that Steve will be twice as old. So just X, X, X5. Then we know from here, just by looking at this, we know that Steve, X is 5, just by looking at this one, right? Right. So from there, it's easy to see that Bill is 5 and Steve was 15 2 years ago. So now they are 7 and 17 respectively. So the sum is 24. Right? It makes sense. Yeah. So another fresh look for this one, I think will give some students some idea that, hey, I can solve problems in a different manner, not just always straight algebra, right? Now we proceed to our third example. So third example is similar to the example that we have in the primary school level. So basically, we just need to cut this one. So this, I'll just quickly go through this. So just give them confidence in spatial intelligence. All right. Now we proceed to example 4. So this one is more for high school. So the question goes like this: randomly put either plus or minus in front of each of the numbers from 1 to 2020. Now we add all of these 2020 modified numbers together. Question is, which of the following statements is correct? Is the sum always even? Is the sum always odd? Or it can either be both? Okay. So, given these kinds of question, what we usually do to start is we can try smaller values first, right? So we start off, we only have two numbers. If we only have two numbers, then we will have four different possible cases, meaning 2 plus two positive numbers, positive, negative, negative, positive, and two negative numbers. And the results are whole here. And notice that 3 minus 1 plus 1 and minus 3 are all odd. So if there are two numbers, the result is always odd. Now let's try the next case. So what if it's 1, 2, 3? So if it's 1, 2, 3, we have a total of 8 cases, right? And they are as follows. So notice that all the results are even numbers. So if there are three numbers, the result is always even. So how about for 2020 terms? What is the answer? So now we will try to solve this generally. All right. So what you will notice here is that for any number, regardless whether it is a positive number or a negative number, that number's parity will not change. It always stays the same, right? So that is what you call invariant in mathematics, something that never change. Okay? So from here, the sum, so regardless of the sum will just have the same parities adding from 1 until 2020, right? And since we know that so we have 1010 pairs of odd and even numbers. So note that an odd plus an even number is always odd, right? Now we have, so what left are all odd, and then odd plus odd is always even. So therefore our answer is our sum is even. Okay, makes sense. Yeah. So we have applied our simple invariant there. Regardless of it looks daunting at first because it seems like how will you know the value? But at the end of the day, whether it's a plus or a minus, it's parity, meaning the property, whether it's odd or even, doesn't change. Therefore, it's always the same. So just add all of them together. So our answer is even. Correct? Another way of doing this, if not like this, would be just check the pattern. So by pattern finding as well. Okay. So notice here that if there is only one term, it's odd. Two terms, it's odd. Three terms and four terms is even. And it follows that like that. So we can conclude that if n is 1 or 2 modulo 4, it is always odd. The sum is always odd. While if n is 0 or 3 modulo 4, it is always even. Okay, so we have two separate solutions for this one. Now we move on to another example. Now there are 9 coins on the table. All are heads up. In each move, you can flip 2 coins. What is the minimal number of moves to make them all heads down? Okay, so how do we approach this problem? Again, we try smaller numbers. If there are 2 coins, then in one turn, we will achieve our desired result. Right? So basically 2 heads. So we flip them both, it becomes 2 tails. How about for 3 coins? If there are 3 coins, after one turn, it will be in a head, tail, tail position, regardless of the order. Now, it is impossible to have all of them in heads down position because whatever move you make, you cannot have all 3 of them in a tails position, right? So, how about for 9 cases? Or how about for a generic n cases? How do we do that? So, let's convert our original equation into a mathematical model. We know that a coin can either have two states only, whether it's heads up or heads down, right? So now let's convert the question to the following mathematical model. The value, we assign value +1 if it's heads up, while we assign value -1 to indicate heads down. Okay? So now notice that each flip changes +1 to -1 or vice versa, -1 to +1. Therefore, we can consider a flip just by multiplying it by -1. Make sense? So under this model, the initial values of all your 9 coins are all +1 because all of them are heads up. And the product of all of these is +1. Now our goal is to make the product -1, right? Because if 9 of them are heads down, therefore you have 9 times -1. So their product is -1. That is our goal. So is it possible or not? We will see. No, but in each turn, we flip 2 times. So that is equivalent to making 2 multiply by 1 operations. Make sense? Multiplying 2 minus 1 will always result to multiplying the whole by +1. Right? Therefore, from here, we can conclude that it will not change the overall value of these 9 values, right? So we started with 9. Since every turn, it is always multiplying just by +1, it will always stay with +1, right, for 9. This means that the product of all the 9 values will always be +1 at all times for our case. Therefore, it is impossible to reach the desired end state, which is all 9 coins are heads down, right? Now we have made our initial question. We have proven our initial question using this generalized proof, right? We have converted our initial question into a mathematical model wherein the values are just plus and minus 1. And it's easier for you to prove such. All right? Now we proceed to the next slide. Okay, so this example, we will be proving the general result of the sum of consecutive numbers from 1 to n multiple times by using different methods. So this is a well-known fact, right? 1 plus 2 and so on until n. Its sum is just n times n plus 1 over 2. We will prove it multiple times using different methods. So first, we prove it using algebra. So we know the sum of the terms from 1 to n is just this one. Now, we reverse it, right? It's the same, but it's reversed. So adding them all together, we have n plus 1, n plus 1, and n plus 1. And there are n terms there, so that's just n times n plus 1. And divide by 2, then yeah, then we're good. Yeah, it's the same. It's correct, right? So we have proved it by algebraically. Now, second proof, we do it using mathematical induction. So for mathematical induction, we have 3 steps. Prove for one case. Suppose it is true for n, then prove true for n equals k plus 1. Right? So for n equals 1, it is correct. Now, it is suppose it is true if n equals 1, which is this one. Right? We just replace n with k. So 1/2 k times k plus 1. Now we prove true for n equals k plus 1. Sorry. There. So basically this 1 plus 2 until k is just this one. And simplifying, we will get 1/2 k plus 1, k plus 2, which is correct. So it is true also for by induction. That this is correct. Now we go to our third proof. So now notice we have, suppose we have n n rows here. Okay. Now what we will do is like this. We place it like that. And just notice what will happen. Yeah, there. So this is our original, right? So if we mirror, reflect this to this, so this figure becomes n times n plus 1, right? So n times n plus 1 all over 2 because this is our original figure. So it is also correct using this way, right? We're just using visualization. And this is correct. Make sense? Now we proceed to proof number 4. So we have two ends here, two different triangle ends. And the sum is just 1, 2, 3 until n. Similarly, we do it reverse 1, 2, 3, 4 until n. Right? So now we add them all, add them. I combine them. So this now, this side of the figure becomes n times n. Right? So n times n is n squared. Correct? So we have 2s. 2s is equals to n squared. Then what we are left here is n. We have n pieces here, so plus n. And then simplifying, again, we will get 1/2 n times quantity n plus 1. Right? And proof number 5, we have an n by n triangle here. So we cut that. So notice that here. So 1/2 n squared is the green part. So imagine this is a square, right? So this is just 1/2 of the square, right? And the blue part is 1/2 n because we have n to p6, but each piece here is just half, right? So 1/2 n. So adding them all together, we also end up with 1/2 times n times quantity n plus 1. All right. So we have proven the sum of consecutive numbers from 1 to n, 5 different types using 5 different methods. All right. So, yeah. So we have already shown 5 different proofs without using any words. Now, can you find more? Okay, that I leave that up to you. But yes, you can still find some more. All right. So just to sum it all up, so those examples that I given you just showed us that math is self-taught. Mathematics advantage among the sciences is that it lies in its generality and abstract nature. The key is not to memorize anything, but to understand just the basic ideas. Another important thing is not one solution for a problem. So there are many problems in the examples that we answered in at least 2 or more times. So as educators, we should always have an open mind with finding unique and elegant solutions. So it's okay to make mistakes as long as the student is trying to solve it using logical thinking and the correct mathematical ideas. And lastly, for this to work, I think the main idea is you have to have some sort of a math club or a community in your school that can do collaboration. So this is basically what MTG is doing. So basically, we're just building a math community, math enthusiasts, so that they will share their knowledge with each other, student to student, student to teacher, teacher to teacher, in a way so that many people will learn and love mathematics. All right. So I hope you pick up some ideas on how to make math more interesting. That's the end of my talk, and have a great day to everybody.
Yes. Okay, thank you so much, Sir Renard Chua, for the inspiring and stimulating way of how to make math more interesting in the classroom. Surely our participants are more than excited to share this in their respective classes. Thank you for encouraging us teachers to tweak our problems to have a refreshing approach on routine and non-routine problems. As what Sir Renard mentioned earlier, it's okay to make mistakes, and what's important is the process that it take you to the correct answer. That's something that we need to take note of. Now, for our third speaker. Our third speaker is also an expert in the field of mathematics, an instructor from UP Diliman Institute of Mathematics. Ladies and gentlemen, let us all welcome with a virtual applause Ms. Hazel Joy Shi as she shares her expertise on symmetry in algebra.
Hi, good morning, everyone. So we will be discussing some algebraic problems that contain some symmetry, and we would like to make use of the symmetry so that we can efficiently solve these problems. And, okay, so let's demonstrate it through examples. So solve simultaneously. So you have here a system of linear equations wherein you see the symmetry because the coefficients here, no 1 to 1, it cycles and on each of the equations. And from here, you can see that for each variable, it should have the three coefficients exactly once. So since we have 1 to 1 that cycles, then x should contain 1, 2, and 1 coefficients exactly once. And same thing goes for y and z. Then maybe we can add all of the equations. So you get 4x plus 4y plus 4z is equal to 44. In here, you expect that the coefficients for x, y, z to be all the same since you're getting the sum of the same numbers for each of the variable. Okay, so next, what we're going to do is we try to multiply or divide it in such a way that what is left in this equation would be the coefficients of x, y, and z would be the same as the coefficient that is repeating from your original equations. So in this case, you have two distinct coefficients, 1 and 2, but the coefficient that repeats is 1. So I want to get x plus y plus z. So to do that, we divide everything by 4. So we get x plus y plus z is equal to 11. So this becomes your new equation. And what we're going to do is that we're going to subtract each of the equations to this new equation. So for example, if we subtract equation 1 by equation 4, what is left with us would be y in the left-hand side, since the x and the z cancel out, and then 2y minus y, so you get y. And then the right-hand side is just a constant, so 14 minus 11, you get a 3. You can also do that for the other two equations, and what you will get would be a solution for x, so we get x is equal to 1 for the second equation, and then for the third equation, you get z is equal to 7. So you get a unique solution, you get 1, 3, and 7. And in fact, you can do the same technique of adding the equations and then rewriting the new equation in terms of the coefficient that is repeating, and then just subtract it on each of the equations whenever the coefficient cycles and you only have distinct coefficients. And then last one, out of the two distinct coefficients, one should only be seen once in each equation. And so what will happen there is whenever you subtract, you will only be having one variable left, no? And then the others will become or will be eliminated. Yeah. So this is a little bit more efficient, no, in doing systems of linear equations as compared to the usual routine of either doing the Cramer's rule or doing one by one elimination of variables, no, especially if your equations contain more than variables. Yeah, so there. So for the second equation, for the second example, so these equations no longer involve linear equations since the first addends have degree of polynomial of 2. But you can see some symmetry here because you have a total of 3 equations and you have 3 variables, but you cycle the pairs of variables that you're going to use in each of the equation. So in the first equation, you have variables x and y involved. For the second one, you have y, z, and then for the other one, zx. So in fact, now all of the ordered pairs now are exhausted here. And at the same time, so the addends no, on the first addends are the product of the 2 variables chosen, and the coefficients no, for the other 2 are the same. We have -1 here. And so how can we work on this problem? We can introduce quote-unquote completing the factorization method. So I'm just using this term on my own. I never heard anybody use a term for it. But the idea here is that you're going to add some constant so that you'll be able to produce an expression that is factorable into 2 linear factors. So a little bit similar with what we do with completing the square, except that we're not expecting a square. No? We're just expecting an expression that is factorable into linear expressions. So maybe we can just say that completing the square is just a special case of this one. Okay, no, so how do we do that? For example, if we look at the first equation, we have xy here. So maybe the linear factors that we're expecting are composed of, so one factor is a linear factor in terms of x, and then the other one is another linear factor in terms of y. Okay, and then in here we have an addend -x, no, which is coming from maybe -1 times x. So that means that x and -1 are indifferent factors. So that means that the -1 should come from y, no? From the linear factor containing y. And then for -y, so the same thing. So you multiplied -1 by y. So that means that the -1 no, is in the other factor. So that means that you kind of expect that you can complete it and get x minus 1 times y minus 1. Okay, so what do we need to add no, to get x minus 1 multiplied by quantity y minus 1? Now we can multiply no, the coefficients no, -1 times -1, so you get a +1. So what if we add 1 no, on each of the equations? And okay, so for this one, no, you can factor this out into what we already imagined earlier. So this is quantity x minus 1 times quantity y minus 1 for the left-hand side. The second equation, so this becomes y minus 1 times the quantity z minus 1. And then for the last one, so we expect to be z minus 1 times quantity x minus 1. Okay, no? So I'll just label all of these equations. So this would be the equations that we will be working on. Okay, and since the operation is multiplication, then maybe instead of adding the equations, unlike the first equation, unlike the first example, we can multiply the 3 equations. And when we multiply, so we notice that you get each factor twice. No? So you get x minus 1 quantity squared, no, y minus 1 quantity squared, and z minus 1 quantity squared. Yeah. Okay, and then so the right hand side would just be the product of the right hand side. No? Okay, And then maybe we can take the square root, no? And so since we're taking the square root, just make sure that we're getting both the positive and the negative root. And so we have x minus 1, the quantity, times quantity y minus 1 times quantity z minus 1 equal either a positive 60 or a negative 60. So actually, we have two equations here. No? So one equation is equated to the positive 60, while the other one is equated to the negative 60. But I'll just label it into as if it's just one equation, since so that we can compute simultaneously. Okay. So okay. So we have this pretty nice equation, and just the difference, no, between the first three equations is that you're just missing one factor, no? So maybe we can divide them, but just to make sure, no, we don't just divide expressions right away. We need to make sure that whatever we divide should not be equal to 0. So how do we argue with that? No? So if you look at the right-hand side of the four equations, all of them are non-zero. And the left-hand side are all just a product of those factors. And we know that the factors should not be equal to 0. Now, otherwise, if one of those factors is equal to 0, then the right-hand side should be also 0. So in this case, so none of them are 0. So that means that all of the factors should be not equal to 0. Okay? So we just need to, so we can just proceed now with the division. So let us divide equation 4 with the first equation. So again, the first equation is quantity x minus 1 multiplied by y minus 1. So after dividing, you get z minus 1 is equal to, so the right-hand side would be 60 divided by 12. So you get a positive or a negative 5. Yan, okay? So if you see the comparison between the first example and the second example, so the addition operations that we did in the first equation are actually multiplication here, and the subtraction that we did in the first example are actually division here. So just to make just to see some similarities here. Okay. And so now we get z minus 1 is equal to plus or minus 5. So that means that z is either, so if this is negative 5, you get a negative 4. And if z is positive 5, then z is equal to 6. And then you also do that for the other two equations. So for the second equation, you will be able to solve for x. So we have x minus 1 is equal to plus or minus 4. So we get x is equal to negative 3 or 5. And then last one for the last equation, so we get y minus 1 is equal to plus or minus 3. So we get y is equal to negative 2 and positive 4. And all right. So now we just need to mix these solutions to form the triples that we need. Okay. So what if we choose z is equal to negative 4? So this of any two factors are positive. So that means that the signs of the factors are all the same. So in here, so if z minus 1 is negative, then from equation 2, that means that y minus 1 from equation 2, from equation 2, we know that y minus 1 is also negative. So that means that y minus 1 is negative 3. So therefore, y is negative 2. So you get negative 4 and then negative 2. And then if you look at the third equation, so z minus 1 is negative. So that means that x minus 1 is also negative. So we get x minus 1 is equal to negative 4. So therefore, you get x is equal to negative 3. Yan. So in fact, although you have many values for x, y, z, you only have one set whenever z is negative. And then what if z is positive? So the same argument, what will happen is that all of the factors becomes positive. And so you also get the positive solutions, no, for x, y, z. And so you get the second solution to be 5, 4, 6. Okay, so maybe for this one, we can solve this maybe if in case that the coefficients for this for those single terms, no, so x, y, and z, if both of them are, if all of them are the same. So let's say if you get xy is equal to 3x, no, plus xy plus 3x plus 3y, and then yz is equal to 3y plus 3z, and then zx is equal to 3z plus 3x. Yun. In that case, no, you can factor out in the form of x plus 3 times y plus 3, and what you need to add, no, would be the square of 3, no, so plus 9 on all of the terms, and then you can just follow the process that we did here earlier. Yeah. Okay. For the next example, so we have here xyz, no, but they are no longer polynomial, no. In here we have denoted that when a real number is inside a bracket, we denote the greatest integer not exceeding that number, whereas when that number is the fraction part. Okay, so hey, based on this definition, you would know that a number is consists of its greatest integer function and its fractional part. And so, and in here, since the number itself, no, the greatest integer function and the fractional part, no, they cycle. So that means that when you look at it vertically, you see that the number, no, will be seen as in the number itself, the fractional part, and the GIF. So what we can do, we can add all of the three equations, and you can combine the fractional part with the integer part, so that becomes a number already. So x, no, plus x, no, so we get 2x. So the same thing goes for y and z. And then the right hand side, no, becomes 6.6. And what we're going to do, we just divide everything by 2. No? So what we want later is to actually cancel out the number itself, no, after we subtract later on. So that's why we just divide it by the sum, no? So divided by 2. So x plus y plus z is equal to 3p. Okay, so now let's use the new equation, no, to subtract, no, to the original three equations. Okay, so if we subtract the new equation by the first equation, what is left with us is the fractional part of y, and the integer part of z. And this is equal to 2.2. Normally, if you have, you still have two variables, no, that are unknown, usually you have infinitely many solutions. So, but for this one, we will exploit the fact that there are some properties for the fractional part and the greatest integer function. So for example, no, the fractional part, you know that it is greater than equal to 0 but less than 1, while the GIF of z is an integer. So what you're going to do, you can dissect the right-hand side into its integer part and the fractional part, and so that becomes the solution to them. No? So the integer part becomes the greatest integer function of z. So while the fractional part becomes the fractional part for y. So why this works? So if we choose an integer lower than 2, you will notice that the fractional part becomes a number greater than 1. Whereas if you choose an integer greater than 2, the fractional part of y becomes negative. Yeah, so what's interesting here is that even if you have two unknown variables, no, you already have a solution and it's unique. So you do that in the same manner for the other two equations. Yeah, so in here, for the second equation, you are left with the GIF of x plus the fractional part of z, and this is equal to 1.1. So again, you just dissect. So the integer part 1 becomes the GIF of x, and the fractional part 0.1 is the fractional part of z. And then last one, for the last equation, so you get the sum of the fractional part of x and the GIF of y to be equal to 0. So yeah, you just need to equate both 0. Okay, so to solve the problem, you just need to add the GIF of the number with its fractional part. So for here, for x, we have 1 and 0, so 1. For y, we get 0 and like 0.2, to get 0.2. And we get z, we have 2 plus 0.1, we get 2.1. Okay, so I guess maybe for this number, this is a little more special. Okay, so the solution to the given equation is 1, 0.2, and 2.1. Yan. Okay, so let's proceed. Okay, so prove that for any real number ABC, we have here 7 times square root of a squared plus b squared plus c squared less than or equal to square root of 3, the maximum of this set. So the set of the absolute value terms, but anyway, let us see some symmetry here. So for the left-hand side, the coefficients are all the same, whereas for the right-hand side, you have here expressions involving absolute value, wherein the coefficients -2, +3, and 6 cycles on each of the terms. Okay, so maybe we have some idea that maybe we have to square something, because you have here squared numbers, a squared, b squared, c squared, but the right hand side doesn't contain any squared, so maybe we need to square something. So let's try. And then for we also need to consider where is the inequality coming from, but actually this comes from the definition of maximum. You know that whenever you have a maximum number, it is always greater than or equal to whatever set that you're considering. So let us produce those inequalities. So let's start with the first element. So let's say we compare the maximum with this term, absolute value of -2a plus 3b plus 6c. Yeah, let's just substitute this maximum with m. Okay, so we have m greater than or equal to the absolute value of -2a plus 3b plus 6c. And then just like what we said earlier, we can square both terms. Since both sides are positive, then therefore their squares should also be of the same relationship. So m squared is greater than or equal to the square root of this term. Yan. And what's nice squaring an absolute value number is that the absolute value cancels out. Yan. And so when you expand this, you can just easily add it with some other terms, which is difficult for absolute value terms. You cannot just easily add terms with absolute value. You would usually have the absolute value when the number inside is negative, when the number is positive. Okay, so do that for the other two expressions. So you get the square root of another number. Yan, okay. And the terms, so just b squared c. Okay, so let's add 3 80s. So you get 3m squared greater than or equal to. So you have most squares of this expression. And maybe we can expand, but we don't need to expand really as usual. But remember that if you square a trinomial, the addends that you will get would be the square of each of the term plus twice the product of any two. So let us look at maybe the coefficient of AB na you expand these terms, no? Because you notice the left hand side here doesn't contain any CA. So let's look at them. Maybe they cancel out. No? So let's look at them. Okay. So in here, from the version, the coefficient of AB would be 2 times negative 2 times 3. So you get negative 12. Okay. And then for the second expression, so the AB would have a coefficient of 2 times 6 times negative 2. So that's negative 24. And last one, you have 2 times 3 times 6. So that's 36. You have negative 12, negative 24, and positive 36. So that is equal to 0. So that means that the added AB cancels out. Okay, and then we don't need to look at BC and CA anymore because we already know that the coefficients cancel out. So yeah, and the coefficient cycles. So that means that the coefficients that we're considering just also cycles. No? So that means that the coefficients for BC and CA should also be 0. So what is left with us would be just taking the squares of these addends. So you have 4a squared, 9b squared, 36c squared for the first equation. And again, since the coefficients just cycle, then you notice that after you expand, each of the terms should have the coefficients for 9 and 36 exactly once. So you can just easily add them. No? So just add them and then just multiply it by the sum of a squared, b squared, c squared. Okay. And then just simplify. So you get 49 times the quantity a squared plus b squared plus c squared. Yan, okay? So what is nice here is that actually this inequality is just the square of these sides. No? So you just need to take the square root. Yan. So just taking the square root, then since both sides are positive, then there is no change in the direction when you square root. So you get 7 times the square root of a squared plus b squared plus c squared, no, less than or equal to the square root of 3, and then just bring back m to the original expression, the maximum of the set. Okay, and then last one. So we need to move on to the last example. So we have here 3 equations but consist of 6 variables. And I want to prove that x squared plus y squared plus z squared is greater than or equal to AB plus B plus CA. Okay, so maybe you would want to square the terms, but then the problem here is that when you square the terms, you are left with some expression containing xy, some term with yz, and then with zx. And the same thing here, you have a, b, b, c, c, a, but you also have some a squared, b squared, c squared that doesn't cancel. So maybe we can make use of the symmetries here. Okay. So in here, in the left-hand side, you can think of it as if the coefficients of 4, 1, and 0 cycles. No? And then the right-hand side, the same thing goes 0, 1, and 4 cycles on each of the equation. And maybe we can write, we can isolate the variables, x, and then just write it in terms of a, b, c. So the same thing goes for y and z. So how can we do that? Okay. So using equation 1, I want to eliminate y. No, but then when I look at the second equation, I have here 4. I need to multiply this by 4 and subtract it by here to eliminate y. But then I have an excess z here that I need to cancel out. So I need to use this last equation. But then again, I need to multiply this by 4 before I add this. So, okay. So let's do that. So 16 times 1 minus 4 times 2 plus 3. No, since you multiply this by 4, you also need to multiply this by 4 so that I can cancel out the y's. Okay. So let's look at the new equation. So the y's and the z's cancel out. And then for the x, so you have 16 times 4, 64. 64 plus the third equation, I have x, so we get 65x. And then again, I just follow this equation, this operation to simplify ABC. So we have negative 15a plus 20b plus 60c. Okay, so let's do that also for the other two. So let's just simplify by dividing this by 5. So we have 13x minus is equal to negative 3a plus 4b plus 12c. Yan, okay? So let's do the same. This time we will be cycling the equations. So we start, since we want to isolate y, so we start with equation 2, and then following by 3 and then 1. No? And then after doing that, you divide by 5. So you get 13y is equal to 12a minus 3b plus 4c. And 13z is equal to 4a plus 12b minus 3c. Okay, so now I can just individually take the squares, so that I can arrive at into something near to x squared plus y squared plus z squared. Since anyway, the coefficients of x, y, z are all the same. Okay, so let's do that. So squaring everything, so you get 169 x squared plus y squared plus z squared on the left hand side. And then on the right hand side, so the individual squares. But again, you see some symmetry here because the negative 3, the 4, and the 12 cycles on each of the expression. So maybe we can also do the same thing as what we did on the previous example. So maybe we can expect that A, B, B, C, and C cancels out. So, okay, so again, let's look at that. So 2 times negative 3 times 4. So that's negative 24. And then here, we get negative 72. And then here we have positive 96. So when you add that, you get 0. Yan, okay? So, yun. So which is okay. So we just need to take the square of the individual coefficients and then add them. Since you know that each of the term should consist the coefficients squares of these 3 coefficients. So we have 9 plus 16 plus 144 times the quantity a squared plus b squared plus c squared. Yan, and 9 plus 16 plus 144 is actually 169. No? So you can just cancel this out. Yan, so you get x squared plus y squared plus z squared is equal to a squared plus b squared plus c squared. Okay, so okay, so basically we just transformed these terms in terms of ABC, but we're not yet done because we want to prove that this expression is greater than or equal to AB plus BC plus CA. Okay, so how can we get those terms? So these are well-known facts. So we know that perfect squares are always greater than or equal to 0. So what we're going to do, we can add them, and just expand them. And then maybe we can isolate the squared terms with those that are multiplied by different variables. So we have here 2a squared plus 2b squared plus 2c squared is greater than or equal to 2ab plus 2bc plus 2ca. And then you just need to cancel out the 2. So you get a squared plus b squared plus c squared is greater than or equal to ab plus bc plus ca. Okay? And then you just need to equate this note from the original expression. So therefore, x squared plus y squared plus z squared is greater than or equal to AB plus BC plus CA. Yan. Okay. So again, this problem is maybe a little bit special, no? But I hope that I was able to impart some techniques here that you may teach to your high school students, especially those that compete in local and international competitions. So that's it, no? And have a nice day.
Wow, thank you so much, Miss Hazel Joyce, for the refreshing and stimulating symmetries that truly gave us an out-of-the-box experience. Yan. And for our last speaker, who will share his expertise on solving inequalities for high school, let's welcome a junior high school faculty member at Zamboanga Chonghua High School. Dear colleagues, let's all welcome with a virtual applause, Mr. Jomar S. Ejedio.
Good morning, everyone, and welcome to this session. And this session will be entitled Solving Inequalities. So before we'll start solving inequalities, let's review some basic concepts about inequalities. And as we all know, an inequality is a comparison between two expressions, relating them in terms of equality, strict inequality, or non-strict inequality. That is, two expressions could be either equal, one can be less than or strictly greater than the other, or one can be less than or equal to or greater than or equal to than the other. So much like in equations, inequalities are governed by axioms, but only two of the axioms for equations apply to inequalities. Okay, so we have two. The first one is the addition property. So with this, we also have two. The first one, if A is greater than B, then A plus C is greater than B plus C. And if A is less than B, then A plus C is less than B plus C, where A, B, C are real numbers. The same thing is true for the non-strict inequality. So when we say non-strict inequality, these are symbols greater than or equal to and less than or equal to. Then we also have the multiplication property. Multiplication property, so we have if A is greater than B, then for any non-zero real number C, if C is greater than 0, then AC is greater than BC. Or we say A times B is greater than B times C. And if C is less than 0, then A times C is less than B times C. Or we write it in shortcut AC less than BC. The last part, or this multiplication property for inequality, is especially important, as neglecting it often creates undue confusion. So when we multiply two sides of an equality by a negative number, we must reverse the sense, or we must reverse the direction of the inequality, or the sense of the inequality must be changed. So let's have some example. Consider 2 is greater than 1. Now, if we multiply both sides by -1, so we end up with a false inequality. -2 is greater than -1 when we neglect changing the sense of the inequality symbol. But if we do, then we have -2 is less than -1, which is a true statement. Okay, that's very important. And that's one way of reminding us and reminding our students as well of doing so. Okay. So let's have some examples. Number 1, is it true that for all real numbers A, B, C, D, we will have AB or A times B is greater than C times D if A is greater than C and B is greater than D? And the answer is no. And so how will we prove that? So in this case, we will use counterexample. So we will use the values A, B, C, D as 2, 1, -3, and -1. So in general, it doesn't follow from A is greater than C that AB is greater than CD by the virtue of having only B greater than D. Since these two variables can be negative, meaning which would reverse the direction of the inequality. So from here, 2 times 1 is 2, -3 times -1 is 3, but 2 is not greater than 3. So that's for our first example. So we have shown it by counterexample. Now number 2, or example number 2. How many of the following statements are correct? So I will be giving you 4 inequality statements. First, if A is greater than B, then A plus 1 is greater than B plus 1. If A is greater than B, then A minus 1 is greater than B minus 1. Number 3, or statement number 3. If A is greater than B, then -2A is less than -2B. Then last statement, if A is greater than B, then 2A is less than 2B. Now from here, we notice that the changes of two expressions before and after, okay, is very crucial. Now, for the first two statements, from the properties also mentioned earlier, when we add or subtract the same number to both sides of the inequality, the sense of the inequality will not change. That means statement 1 and 2, or the first two statements, are correct. While for the 3 and 4, it involves multiplication. Now, when we multiply or divide, in that sense, both sides of the inequality by the same positive number at the same time, the direction of the inequality sign will not change. Whereas when you multiply or divide by the same negative number, the inequality sign or the sense of the inequality must be changed or reversed. That means statement 3 is correct, while statement 4 is not. So how many of the following statements are correct? The answer is 3. Okay? First, second, and third statements are correct, while the number 4 or the fourth statement is not. Okay? So I hope that is clear. Okay, let's proceed to example number 3. Given that A, B, C are real numbers, and B is less than A but greater than C, then which of the following is correct? So the same thing, I will be giving you 4 statements here. First one is AB is greater than BC. Second is A plus B is greater than B plus C. Then A minus B is greater than B minus C for the third statement. And for the last statement, A over C is greater than B over C. Now, from the properties that we discussed earlier, or I have shared earlier, it's obvious that statement B is a true statement. Okay? Since A is greater than C, then A plus B is greater than B plus C. Okay? Now, when B is less than or equal to 0, this contradicts the statements A, C, and D. That means statement B is correct. How else will we be able to show that these statements are true? So we can use examples or substitution by putting, or shall we say, letting values A, B, and C, such that again A is greater than B is greater than C. And from there, we can see that the statements A, C, and D are incorrect. And take note that there will be two cases. No? There should be two cases wherein B greater than 0 and the other one, B should be less than or equal to 0 for you to be able to see the differences. And whenever it is true for all or for the both cases. Okay? So let's proceed to the fourth example. If real numbers A is greater than 1, or for real numbers greater than 1, compare the magnitude of real numbers M equals A, N equals 1/3 of A plus 2, and P equals 1/3 of 2A plus 1. So we can solve it, we can solve this item into two ways. First is assuming a value A. In this case, I assume the value as A equals 2. Then automatically M is equal to 2. Then N is equal to 1/3 times 2 plus 2, which is 1/3 times 4, because 4/3. Then for P, it's 1/3 times 5. So we have 5/3. This will tell us that P is less than M but greater than N. So we should also arrive at the same answer when we have this second solution. Now, since A is greater than 1, then A minus 1 is greater than 0. And we have M minus P. So the value of M, which is A, the value of P, which is 1/3 times the quantity to A plus 1. Simplifying that, we have A minus 1/3 greater than 0. That would imply that M is greater than P. Next, we also have P minus N, where we have 2A plus 1/3 minus A plus 2/3. So where do we get those values? From the given, right? Then simplifying, so we have A minus 1/3 is greater than 0. Also, from that, P, we will be able to imply that P is greater than N. That means M is greater than P is greater than N. Okay. Example number 5. If the solution set of the inequality 3m minus 2x is less than 5, with respect to x is x is greater than or equal to 2, what is the numerical value for m or of m? So let us consider m here as a constant. Then we solve the inequality to obtain x. And so with that, x is greater than 3m minus 5. Okay, so how do we do that? So we have the first thing to do, okay, is like solving equation. Okay, it's just like solving equation. But again, take note the sense of the inequality symbol. Okay, when we do some operation, solving x in terms of m. And then we use this solution set, x is greater than 2, and get the equation of m, where we have 3m minus 5 over 2 is equal to 2. Solving for m, we have m equals 3. So the answer is m equals 3. So that's the numerical value for m in that inequality. Okay, so let's proceed to some more examples. Okay, the next example is good practice for grade 7. Provided that they are done or they already mastered operation in integers and substitution. Okay, it's very important. Substitution in literal equations, no? Having variables and combining those stuffs. So let triangle be an operator so that A triangle B is equal to AB minus A minus B plus 1. Then we compare negative 3 triangle 4 and negative 4 triangle 3. So which one is greater? Which one is smaller in terms of value? And so how will we solve this one? We will, therefore, in this case, we have to carry on the process or the operations of the defined by triangle. So we have negative 3 triangle 4. So we have negative 3 times 4 minus negative 3 minus 4 plus 1. And so we have negative 12. Okay? Again, make sure if we give this to our students, they have mastered the operations involving signed numbers. Next is negative 4 triangle 3. So we have, by substitution, we have negative 4 times 3 minus negative 4 minus 3 plus 1 equals negative 10. So from here, we will see that negative 12 is less than negative 10, or negative 10 is greater than negative 12. Meaning, negative 4 triangle 3 is greater. Or shall we say, negative 4 triangle 3 is greater than negative 3 triangle 4. Okay? So that's our example number 6. Okay, let's proceed. Now, next number 7 is a word problem. Yeah, I forgot to give the final answer there. Okay, let's proceed to example number 7. So example number 7 is a word problem. Okay. So as a math teacher, we have to what do you call this? We have to relate these concepts to our students that these concepts are useful in their daily activities, or it can be found in some of our daily activities in school, at home, or anywhere else. Okay, number 7, we have this problem. 22 students from section 1 of grade 8 of a certain school went to plant trees. The total number of trees planted is not less than 33, not more than 44. And there are 10 trees in each group. In average, at least and at most, how many trees are planted by each student of grade 8? So to solve this problem, we have to set up an inequality sentence. Now, of course, before we'll have the inequality sentence, we have to have our variable or our unknown. So let X represent the least number of trees planted by each student. Okay? Take note that there are 22 students. So meaning 22 times X, okay, will be greater than 330 but less than 440. Why is that so? Because in each group there are 10 trees. So 33 times 10 and 44 times 10 respectively. So we will be able to set up the inequality as, again, 22x is greater than or equal to 330 but less than or equal to 440. Solving for x by dividing the complex inequality by 22. So we have x is less than or equal to 15. Sorry, x is greater than or equal to 15 but less than or equal to 20. So there. Meaning, each student planted at least 15 trees and at most 20 trees. There you go. Example number 7. That's example number 7, I mean. So we'll proceed to example number 8. It is known that the solution of equation 3 times the quantity x minus 2a plus 2 is equal to x minus 1. On x suitable for inequality 2 times x, 2 times the quantity x minus 5 is greater than or equal to 8a. Find all possible values of a. So we have two sentences, equation and an inequality. So with that, the solution for the first for the equation like will be substituted, okay, or will be used for the second for the inequality. Again, solution in equation will be put as substituted in a inequality given there. So from here, we will solve the equation in terms of x. So we know that the solution for the equation there on x will give us x is equal to 6a minus 3. Okay, so simple solving linear equation. Okay, now when we have this value of x now, as I've said, we will substitute that into 2 times the quantity x minus 5 is greater than or equal to a. After that, solve for a. And there you go. A will be less than negative 6.5 or negative 6.5 or negative 13 over 2. There. Okay, so thorough solving is not already it's not shown in this slide. Okay, so you can do the solving part on your own. Okay, also we can give this kind of items to our students for like thought-provoking item, okay, for extension of what they have learned from the basic in the classroom, in our sessions, in our classroom sessions. We will extend it to items like this. Okay, that's example number 8. Example number 9, solving. Okay, we will have solving now. 2 times, or solve for x given the inequality, 2 times the quantity x plus 1 plus x minus 2 over 3 is greater than 7 halves x minus 1. Okay, so the same thing as solving equation, but the only thing that we have to take note here is the sense of the inequality symbol. Okay, so there. We will multiply first the inequality by 6 on both sides. Okay, then simplify. Okay, simplify. And so we have 12 times the quantity x plus 1 plus 2 times the quantity x minus 2 is greater than or equal to 21x minus 6. It follows that negative 7x is greater than or equal to negative 14, dividing both sides by negative 7. And take note that we are dividing both sides by a negative number, meaning the sense of the inequality, the direction of the inequality symbol will be changed from greater than or equal to less than or equal to. So final answer would be x is less than or equal to 2. Okay, so that is for our example number 9. Okay, example number 10 is also solving. So solve 3x plus 3 over a squared minus 2 is greater than 1 minus 2x over a. So notice in this example, there are 2 unknowns, there are 2 variables. So meaning you just have to solve this one variable in terms of the other. So in this case, I will solve it x in terms of a. Okay? Now, so solution. It's obvious that a is not equal to 0 because if that happens, we will have an undefined, what they call this, fraction or inequality. So that's not possible. Okay? So a should not be equal to 0. So we multiply both sides by a squared and then simplify. Then we will have this. Now, combining like terms, then factoring out common factors. Okay? So the left side of the inequality will be with x, and on the right side will be with a. Now, it is in a quadratic form, so you have to factor it. And so we have the quantity 3 plus 2a times x is greater than the quantity 2a plus 3 times quantity a minus 1. After that, what will happen? What we'll do? As I've said, we will solve it the one variable in terms of the other. So x in terms of a. Now, We will divide this into 3 cases. The first one is that when we have 3 plus 2a is greater than 0. Okay, then solving for a, so a is greater than or equal to negative 3 halves. Then substitute that for the x, or for solving for x now. So x is greater than a minus 1. Second case is that when 3 plus 2a is equal to 0, that is, a is equal to negative 3 halves. But there's no solution. How come that there's no solution? Because if we'll try to substitute that value to the original equation, we will have a 0 greater than 0, which is a false statement. So that will be considered no solution. And lastly, case 3, when 3 plus 2a is less than 0. So we have case 1, case 2, case 3, following the trichotomy property, no? A number is either greater than 0, equal to 0, or less than 0. And so solving for a, we'll have a is less than negative 3 halves, thus x is less than a minus 1. So therefore, there are just 2 possible answers here, or 2 possible solutions. X is greater than a minus 1, and x is less than a minus 1. Okay, so last 2 example, guys. According to the figure below, which of the following is the correct statement? So we have this. Now, from the first figure, we know that 2a is greater than 3b. Then we have 3a is greater than 3b, which will imply that a is greater than b. Hence, b can't be the answer. From the second figure also, we know that 2b is greater than 3c. So b is greater than c. Hence, option D is also not the answer. Now, since 2a is greater than b and 2b is greater than c, then the ratio between the values of a and b is 3 is to 2. The same thing goes with the ratio of the values to b is to c, 3 is to 2 also. Now, I'm putting them into one comparison. The ratio of a is to b is to c is equal to 9 is to 6 is to 4. That implies that the ratio of the values of a is to c is 9 is to 4. Now, meaning 4a is equal to 9c, thus a is greater than c. Meaning the correct answer here is C. A is greater than C, or option C, A is greater than C. Okay, last item or last example before I'll end. In a knowledge quiz contest, there are 25 questions in total. Each question has 4 answers, and in which one answer is correct with 4 points for correct answer. 2 points will be deducted for wrong answer or no answer. Now, if a participant who will get 60 points, then he will be receiving an award. So meaning, with this, how many questions should be answered to get an award? Okay, so if we're like joining contest and we know the quota, we will be able to at least set the standards. Okay, so solution, again, we will be solving this using inequality. We'll be setting up an inequality statement or sentence. And so with that, let X be the number of questions answered correctly. So meaning the 25 minus X in that sense will give you the number of items answered incorrectly, right? If X will be the number of items answered correctly, then 25 minus X will be the number of items answered incorrectly. So setting up the inequality, so we have 4X minus the number 4X, no, in terms of points now, minus 2 times 25 minus X, that's the number of points also deducted for wrong answer, is greater than or equal to 60. Now, solving for X will give us 18 and 1/3, or 18.3333. Okay, so should we answer 18? Okay, so how do we know that? So we can go back to the inequality and solve, or substitute that value. Because 18.33 is not an integer, and we cannot have an item, 18.3 item, so cannot. So we'll just have to either choose 18 or the 19. Okay? So if you substitute 18, that will not give you a true statement. Okay? Substitute X as 18 in the given inequality there will not give you a true statement. That means we have to choose 19. Thus, at least 19 questions to be answered correctly to receive an award. Okay? So this is a very good item as an exercise for our students. Okay. So that's it for today, and thank you for being with me this very morning. Edit mo to, Kevin. Ha? Again, thank you for being with me today, and that's all I can share. And I would like also to thank the MTG and the Phoenix Publishing House for this opportunity for being with you guys. And hope to see you into next free webinar. Okay, see you to some other trainings sponsored by our generous sponsors. Okay, so that's all for today. Again, have a nice day ahead. Bye-bye.
Okay, thank you so much, Mr. Jomar S. Ehedio, a truly interesting and unique way of solving inequalities. What a really interesting and jam-packed day. We had a series of wow experiences from one solution after another. We learned a lot of new things. I myself have a lot of takeaways. I hope everyone also have the same experience as mine. What a unique and distinctive way of celebrating our MTG's Silver Jubilee. Truly and evident that we are looking forward for more interesting years with MTG. Earlier, we had the winner of Sharp Calculator for the elementary level and now we are ready to have our winner for the high school. Is everyone excited? Okay. For our high school winner of Sharp Calculator ELW531XH model for high school, drum roll please. And our winner is from Dr. Arcadio Santos National High School, Parañaque City. Congratulations to Miss Renalyn Albesa. Wow! Not only a full pack learning, but we are also blessed with such great tool that we can use in our classes. So congratulations, Miss Renalyn Albesa. You have a great tool to use in your classes. It seems that our lecturers gave us a clear-cut discussion since there are no questions. Yeah, right? Looking at the FB comments, all but gratitude that we see thanking our lecturers for such a great talk. No one can and will compare to the legacy that MTG shared with us teachers and to our champions for the past 25 years. And we witness an inevitable continued search for excellence. Truly, this webinar will go a long way with a great number of participants from different parts of the Philippines. Our purpose will definitely radiate on boundless magnitude. We are truly blessed with such opportunity given to us to be able to listen and learn from experts. With all gratitudes, thank you MTG for your continued effort to provide our teachers and trainers with quality and prominent trainings that will radiate to the students that we have here in the Philippines. DepEd had never been alone in providing excellent seminars because MTG is always opening opportunities for trainers to be more confident and competent in mathematics advancement. To our speakers and lecturers, thank you for the learning and effort, time and preparation. All the experiences that we have today, this is something that we're going to put in our pocket and be ready to share it to our class, to our students in the next coming days. Thank you so much, Phoenix Publishing House Incorporated, for celebrating the 25th founding anniversary of MTG Philippines and for being their partner in bringing mathematics education in the Philippines at par beyond international standard. Also, we would like to thank Sharp Calculators Philippines for their partnership and continued support in MTG's endeavor to bring the best from our champions. This celebration is truly a success because we all have you with us this morning, the administrators, our friends, teachers, trainers in our side, one in the endeavor to help the Department of Education uplift the mathematics education in the Philippines beyond the realm of international standards. We are already on the last strand of our celebration. This may be the end of this event, but this is the beginning of a great celebration to come. To our participants, please be reminded to fill up the evaluation form where the link will be posted in our FB page. in the MTG FB page, you will be receiving your certificates to your email. Yeah. And of course, we're not going to forget that as a sign of gratitude for being with us until this time. To MTG, happy 25th anniversary. This is an exceptional way of celebrating our silver jubilee. Congratulations to a quarter of a century of bringing excellence in the field of mathematics. A promising commitment of MTG's continued quest in making a difference in the mathematics education, and a strong bind of trust that we teachers have in MTG family. So as one family, we thank you all and God bless to all. Bye everyone. Until next time. See you again on our next webinar.